up at night, yeah. Make all the demons quiet, yeah. We were built to thrive, yeah. I think that we've all had enough. What keeps you up at night, yeah. Make all the demons quiet, yeah. We were built to thrive, yeah. I think that we've all had enough. Yeah, I think that we've all had enough. Sick of dealing with the old plan. They know that we're calling it wrong. You got me like, oh yeah, I think that we've all had enough. Sick of dealing with the old plan. They know that we're calling it wrong. Hey, it's too late to try to go contain it. A generation fueled by creation. We live lives on a small screen nation. We control the airwaves, no negotiation. I refuse to think we need saving. Something good will come from creation. And when we think that the world is too anxious, we'll adapt, evolve, survive, and save it. What keeps you up at night, yeah. Make all the demons quiet, yeah. We were built to thrive, yeah. I think that we've all had enough. What keeps you up at night, yeah. Make all the demons quiet, yeah. We were built to thrive, yeah. I think that we've all had enough. Oh, yeah, I think that we've all had enough. Sick of dealing with the old plan. They know that we're calling it wrong. You got me like, oh yeah, I think that we've all had enough. Sick of dealing with the old plan. They know that we're calling it wrong. Hey, oh yeah, I think that we've all had enough. Sick of dealing with the old plan. They know that we're calling it wrong. You got me like, oh yeah, I think that we've all had enough. Sick of dealing with the old plan. They know that we're calling it wrong.
Nobody is coming to save you. Get up. Be your own hero.
All right. Good evening, ladies and gentlemen. Welcome to Sovereign Soul Unchained Mind. Coming to you live, 250 miles above your imagination in the International Fake Station. I've got my good friend back here, Witu Low, and he's just making sure I toe the party line tonight. Whoa, look at here. We got Droppity with MCAX here tonight. I see that Uncle Artie's already out here fucking losing his mind about this shit right off the bat. And that's interesting. He thinks that gases can have a weight outside of containment.
Show me one.
All right. Let's see. Oh, yeah. Yeah, I feel that. Yeah. Oh, my God.
Heavy.
Obviously, do not understand how gases go, how they operate, how they behave. Interesting. So we got Push Button 62 in here. Jehovah's lovely daughter, Barbara. You can't explain that they are spears, Artie. Your reification questions are really quite fun. Right. They're very fun. Go ahead and hit that link, Uncle Artie. Come on up. We can talk about it. No worries. Air is the shape of smiles. Good evening. Dreamy Lynn is with us as well. We got, of course, Uncle Artie is with us here, losing his mind about this whole subject. Gas. What is the shape of gas? What is the shape of air? Anybody know what the shape of air is? Does air have a shape? No, air. Well, it can have a shape if it's in a container. So if you had a cookie jar and it was empty, there's air in there that's in the shape of a cookie jar. But you remove the cookie jar, it doesn't have any shape anymore. It won't. You can't. So that's the only way. Because, of course, gas molecules are zipping around, and they're only going to change direction when they bounce off of something. That's how they fucking work. Interesting. One more quarter's with us, Shawnee B. We've got, let's see, Anson, my good friend over the pond. He's over here with us tonight. You still fail, it seems, however far up you go. Let's see who else we got that I didn't see. Push Button 62. Logical Observations, Mr. Leahy. Who? Earthship Bears with us as too. Let's see, Shawnee B. ZXL Masters with us here again tonight. Let's see, I think RPB 67 and more are sure to come. Thought we'd talk about gas here for a little bit. The shape of air. how gas behavior works. We can already see that through the, I don't know where they get this. Jupiter is a gas giant. Well, what's causing the gas to be there? How does it be there? It was because of gravity. Well, we already know gravity has absolutely, even if it does exist, even if gravity did exist, it doesn't have any effect on gases, right? I mean, the only way you're even going to have a gas to have pressure at all is with containment. It has to have containment, otherwise it's not going to have any pressure. That's happening. Just nope, ain't happening. That shit's empty, man. Shit's empty. It's empty. So no, it can't have a shape. That's why often you'll hear me say the Atmos, okay? And I just leave it there because it doesn't have a shape. Gas cannot have a shape other than the containment that it's in. So we don't know really what the shape of the containment is. We can speculate. There's some pretty good theories that it may be a dome. There's other people believe that it may not be. I don't know. I can't verify it one way or the other. The only thing is that I know that there must be containment in order for there to be any air pressure. What isn't necessary to know the cow or what color the cow was to verify that a steak sitting in front of me came from a fucking cow, right? I don't need to know who the cow was. I don't need to know who raised the cow or even where the fucking cow was from. All I need to know is that in order for there to be a steak in front of me on a plate, it came from a fucking cow. Okay, so how do I know the air is contained? Because it must be. It must be. How do I know that this steak is from a cow? Because it's beef. It had to come from a fucking cow. Okay, it's that simple. This shit about reversal of burden of proof. We got to watch this. We got to watch this. They do it all the time. And then like we had Artie was in here losing his mind about the fucking gas giants. Well, you only know it's a gas giant. You never saw a gas giant, not with your telescope. Not with your eye through a telescope. Have you ever seen what they tell you these things are? No one has. Okay, that's just, let's get that right out of the way. And so to assume, and it's just a reification, that the air on Earth is held due to something that's never been proven called gravity. Yep. Then they can place this assumption onto other objects that you can't really see, you can't really touch, you can't really verify, tell you whatever they want to about it, and you'll believe them. You'll believe them because after all, they're scientists, right? Or that's what they call themselves anyway. You know, there are people I know that call themselves physicians that aren't worth a fuck. Who's that character we got here that he amputated the wrong leg off of somebody, man? Hong. Yeah, Hong. Yeah.
Two people shots back to back and killed them.
Yeah. I mean, wow. Yeah. So and so that doesn't mean anything. Yeah, I mean, it's so when somebody says I'm an expert or I'm this, that, or the other, it doesn't fucking mean anything. I know a lot of people that claim a profession and they suck at it, you know, just because they claim it. I mean, we know a lot of people that claim to be carpenters and they ain't worth a fuck, right? You know, but hey, they still do it. So this is what you have to be careful with is putting your trust off into shit, especially when it comes to nonsensical things like this that you haven't even thought of yourself. So what is the shape of air? Anybody, it doesn't have one. Okay. What is the weight of air? Well, air or gas can only have a weight when it's in a contained volume. And that's going to depend on the amount of the volume that's contained. That's all you got. But outside of that, no, there's Crunchy Bee lurking. But I noticed you showed up to let us know you're lurking. Keeping us all looking over our shoulder. Are you a Crunchy Bee? Don't be doing that to us now. Be a nice guy. So I also ran across some stuff here today that I wanted to. And if anybody's got anything on that discussion, or if Artie would like to come up and discuss his gas giants and how he knows, I know what he's going to say is spectroscopy, right? We use spectroscopy. All right. You tell me how that works. Okay. These people who want to claim the use of spectroscopy, I want you to go through step by step how the fuck that's done, and we'll see if it holds any water. It's a cool word, but breaking the light you receive from something and you're looking at through your own Atmos, God knows what other medium, and then trying to break that light into a spectrum and deduce what it's made of from that, that's not even close to scientific at all. Okay. I think Flatzoid was saying he uses spectroscopy all the time in his work, and it must be contained in order to work it right. Gas giants are nothing more than corporations. Yeah, like Shell and Exxon and the rest of those, BP, British Petroleum. You know, that's what they got their whole foothold into Saudi Arabia. If you've ever seen the movie Lawrence of Arabia, that's all about that shit, man. It really is.
Yeah, I know they got a big deal going on. Arabia, whatever it
is. Yeah, because spectroscopy, a can of farts from across the warehouse or something, right? You know, you can't do it, you know, especially if somebody cut. Yeah, this is the crazy shit that they're trying to say canned farts. You know what? There's people probably right now on this fucking OnlyFans and shit making a shitload of money selling farts to pervert dudes and shit. You know, I guarantee it, man. People are so fucking sick. Yeah. It's not even funny. But I noticed here tonight,
people little bit too. They sick too.
Yeah. Well, that's what I'm saying. I mean, shit. You want to buy a fart in a jar? Really? Okay, I'll do that. What the fuck? That's easy. How much work you got to do into that? You know,
would buy shit like that. Man.
No way.
Shit, man. You see something on TV, you know, buy 3, get an extra one for $19.99.
Yeah, I can see commercials too. There'd be competitions for it. Are you sick and tired of the random, regular fart in a jar? Well, you need super fart in a jar. Ooh, Mom, it's extra gross. You know, I don't know how they would go with that one. Farts. You got every kind.
We got opium farts.
You got every kind of fart you can think of.
So farts by the jar.
Anyway, before I come on here tonight, I was checking out on Modern Day Debate. I didn't even know this was going to happen until a little while ago. And then I forgot about it. And then I was like, oh yeah, that's back. That's on tonight. And it was Austin Whitsitt was going up against Globeface and on Modern Day Debates. And it was pretty good, man. Pretty good. I mean, given the one, I got to apologize. I was really hoping there would be more of a crescendo, so to speak, from the one last night and the night before that we looked at with Dustin Nemo and Ross going against Ozian and FTFE. But that was just like, it was like a slap. I don't even know what the fuck that was. If I didn't know either way, I wouldn't be convinced either way by what was presented. That's what I have to take home from that. Of course, I don't believe we went to the moon. It's physically impossible. So that's my 2 cents. But like I said, if I go into it with a neutral thing, and that's what I had to do when I started looking at all of this stuff, is go into it with a neutral mind. Go into it completely neutral. I don't have an opinion one way or the other. What do the arguments tell me? Right. What does the logic and the data tell me? That's how I have to look at everything. Because if you go in already with your mind made up, it's going to be twice as hard for you to absorb the information. It's just that simple. And that's the key to an unchained mind. Right. Absolutely. Absolutely. Those debates cause more doubt. Well, I don't think so in this case, Shawnee. Are you related to Crunchy? Just kidding. Just curious. I mean, I'm not making a joke or nothing. It's maybe you guys are like know each other or something. I don't know. Saw the bubble burst. Which bubble bursted? What bubble bursted? FE Nation. Don't leave us in suspense. What are all 13 types? What are we talking about here? You guys got your whole own fucking thing going on over there, I think. Anyway, so I thought I'd pull this thing up and see if we can let this go for a little bit, and we'll check it into it, because I was watching it for a little bit out in the front room before I came in here. And I was at a point where I saw where Globy McGlobeface. Who the fuck thinks up that name? I mean, it's kind of funny. It's a funny name. It really is. But
Well, they could come
I would expect somebody with a name like Globy McGlobeface to be like more kind of humorous in their presentation type shit, you know.
Yeah.
Whereas, you know, I don't know, the name just doesn't fit the personality. You don't know any Crunchy? Okay. Well, we have a friend of ours here at the show, Crunchy B. He's a pretty cool dude. Maybe you'll see him in here sometime. He was lurking. He let us know that he's lurking, Shawnee.
Yeah.
So anyway, I got this queued up to where it started, and I think this would be good because, listen, my man Austin, he puts down shit. And again, this is what people do, and I think it's funnier than shit. Oh, Austin just said a bunch of word salad, and it's like, tell me you don't understand what he said without telling me you didn't understand what he said. And I listen, sometimes I go, what the fuck did Whitsitt say? And I have to back it up and listen to it again. And I dissect it and I'm like, okay. But he's like, I do that sometimes too. Hey, Melodome, what's going on, my man? You know, why use 20 words where you can use 3, right? But the problem with that is a lot of people don't understand what these words are, and a lot of this. So what I try to do is, if I do use them, I break it down so that it's in an understandable sense, so that it's something that's relatable. You know, because a lot of times, and people will shut down when they hear words like that. They're like, oh, fuck, it's like school again. No, stop, quit, you know, and it's just a natural reaction. So anyway, let me get this going here and we'll see where it goes. I didn't see the very first part of it. I only caught like in the middle. And it seemed like it was pretty good. And I thought, you know what, I'm going to share this. If people hadn't seen this yet, they need to. It's pretty good. They get into a lot with perspective. And that's one thing that I like Whitsitt for, is he's got the math shit. You know, he's got the math. That's the thing. Yeah, I like when they're not trying to sell tickets to something too.
Just go over here.
Yeah. Which one now?
That nowhere.
Which
math.
This guy?
Yeah.
Yeah, that's Whitsitt.
Right.
That's Austin Whitsitt over here on the right. And this is Globy McGlobeface.
Yeah,
This is Ryan. I have to say, Ryan did a pretty good job moderating, but there wasn't, and the guests seemed like they were already, you know, pretty well behaved. So that's pretty, unlike the last 2 nights. It was just people interrupting over top of each other and shit, you know. Whitsitt is destroying Gooberface. Yeah, it was looking like that. Globy McGlobeface is an idiot. Yes, I'm getting that. Sitting there, I was like, you know, I picture him as like he's a cab driver type guy, you know, or you know, not being a cab driver is a bad thing or anything like that. I mean, it's just like that's the kind of, I see him as like a New York City type guy talking on the street. Hey, yeah. Go Mets, you know, or whatever they like, you know.
Good evening, everybody. Welcome to Modern Day Debate. Tonight, we're going to be debating Globeface, Flat versus Globe versus Austin. Geez, I'm reading this all out of order. My bad. Flat versus Globe. It's because your name. Globy McGlobeface versus Austin Whitsitt. And 10 minutes on the floor for you, Austin.
Read the comments.
Nice.
Nice. Gets it all messed up.
All right. I hear some audio, but I don't know where it's coming from. So heliocentrism has never been proven, and it's a religion. And so I guess I just saw in the email, it says like keep Austin on subject or something. And I just heard it's globe versus flat, and it should have been assumed. I don't know what the echo's from. I think it's from someone else though, but I hear me echoing.
I don't hear an echo, and I don't have any speakers on.
Okay. I don't know. I do, but it's all good. Okay. I have no idea. All right. Anyway, so that's so annoying. All right. So, but obviously the actual subject is that the earth is supposedly a specific thing, and it's a model, right? There's a mainstream globe model. What is that, dude? And that's what we're going to talk about. So heliocentrism is part of it, that the Earth is moving. Obviously, here they'll tell you that what is going on. That is just philosophical models. I'm so confused. I hear me talking delayed.
Your talking is coming back to you delayed. Okay. Do you-
Okay. Maybe. I don't know what's going on.
Ain't it fucking funny though? Every time it's the flat Earth side has some kind of technographical issue that Ryan doesn't understand or see. Come on, man. These guys got to do better than this.
But
Maybe reconnect.
If you want to try dropping out for just a second here, let's we'll end the screen share. If you want to try rejoining, just because it seems to be
Okay.
happening just on your end. So if you want to just pop out for a second and then pop back in, we'll
Sure.
try to get you going again, because it seems like if you're having a delay issue, it's only going to probably trip you up going forward. So
Okay.
yeah, just just click back on the link I sent you, and we'll try rolling it again. We'll reset the timer.
All right, sounds good.
All right, we'll
I'll
see
be
you in a
right
second.
back. Sorry.
No problem, buddy.
Yeah, I can't. If I'm hearing an echo, I can't get 3 words out. It
No.
just it short circuits my brain.
There we go.
Hey, Austin. You working?
Yeah, I guess I have no idea. Everything just went crazy. Right.
Okay. Well, if you're working now, let's restart your timer. And welcome to Modern Day Debate, everybody. Tonight, we're going to be debating globe versus flat Earth. First 10 minutes is on the floor for you, Austin Whitsitt.
Well, yeah. So, I saw. Make sure Austin doesn't go off subject. My experience is that normally that happens the other way around. But anyway, the subject is the Earth actually what we've been told, and that is the globe model. What always happens is people want to focus specifically on sphericity because they can't defend the vast majority of the model, but it's a model, it's a package deal. It says it's tilted, wobbling, spinning, revolving around the sun as a sphere, and that it's also curving. So here's a quick deception timeline of how this kind of was born. The idea was
Cool beans,
and
Sean.
here's the government's involvement with a bunch of stuff. Purely coincidental.
What the fuck is going on here?
My goodness. What is going on? That's better. So, okay. Jeez Louise. Anyway, it's a package deal basically is the point. So here's a deception timeline. We don't have time to go through this, but you can take a screenshot. Pretty telling. All the intel agencies being founded right after we went and took a little trip to Antarctica. But it's just a coincidence, all of it's a coincidence. So heliocentrism has never been proven, and it is a religion. And I know that that's like a triggering word, but it's a belief system built upon the doctrine of men that requires faith and blind belief. And that's what this is, right? It doesn't require it be about a deity. So here is physicist George Ellis, one of the people that told the truth about this, which is I could create a spherically symmetrical universe with Earth center, and it would answer all cosmological data, right? But we choose the one that we believe in based on philosophy, but a lot of people try to hide that fact, right? And so that kind of brings us into the first part, which is the Earth actually moving. The claim is that the Earth is spinning 1,037 miles per hour east of the equator. That's the tangential speed. You have the angular speed of 15 degrees per hour. And so it's a very specific motion claim.
I had it all set up to go on there, right? And then Sean started being a pisshead in the emails. I showed about that. I was going to debate Sean Hawkins, and they said for first timers, they wanted to have you team up with somebody. And I was like, cool, I'm good with that. Do you pick or do I pick? And he's like, I'm not going to do it unless he agrees to bring a map, a model, and some other fucking bullshit. And it's like, dude, you can demand those things, but all you want to, we'll talk about those in the debate, but you don't get to just start making fucking demands, And so they just emailed me back and says, looks like Sean's not interested. Oh yeah. And he said, oh, and I don't need any help. So he, it's like, look, it's not your platform. It's their platform. This is how they do it, man. So that was in the works, but yeah, I could team up with Iron Horse. Flatzoid and I have talked a little bit about doing something together on one of these MDDs, or on. I did one on Jeranism with Brenda. So I don't know, man. We'll get one going. Yeah, he is. He's a joke. He absolutely is, and it'd be like low hanging fruit, because that. How long would that last? Like 10 minutes? Fuck.
And that it's actually wobbling 3 to 4 different wobbles, depending on the source you look at. And of course, you can't even replicate something actually simultaneously moving 4 different wobbles, but whatever. So these are the supposed motions. And we're tilted, wobbling, spinning, and then we're orbiting the sun 66,000 miles per hour while we fly through space. Here is someone writing a biography about Einstein. No physical experiment ever proved that the Earth is actually in motion. Here's Einstein himself telling you that all terrestrial experiments were a negative result. That means any experiment on the Earth can't detect that the Earth is moving around the sun. And if you believe in the current model, you have to believe that you can never actually measure, detect, or prove that it's moving around the sun. And anyone that doesn't agree with that disagrees with their model, and therefore we wouldn't even be really debating at that point.
Yeah, they all act like that, Mr. Lee. That one night when McToon lost his shit and canceled the debate with who was it, with Ross and Matthew, and he flew off the handle that night, and it was very telling in his words. He does not get to appear on a show with me, like it's a privilege, like it's some kind of a wonderful thing to be on a debate with the guy. He's a childish little nonsensical asshole. I don't know why he thinks he's somebody.
You're going to say that also there's a coordinate system, right? A kinematic equivalence in the coordinate system. If the sun moves around the Earth or vice versa, it's equally valid. Here he is saying that at terrestrial experiments, he's saying no optical experiment. Even though I believe that the Earth is revolving around the sun, I've come to the conclusion that no optical experiment, optics and physics is, of course, light, can actually detect the motion of the Earth. And light is our most precise form of measurement for motion. This comes back to Michelson-Morley, the most grossly misrepresented test by every single person that argues on behalf of the globe. They don't know what this test is actually about. They claim it debunked the ether. If you throw the ether out, you still have to explain why it didn't detect the motion of the Earth. And I could just pull Einstein up. I've done it 100 times. They keep saying it. Einstein said, without the ether, we still have to explain why we didn't detect the motion of the Earth. Then they invoked contraction. They invoked time dilation. They said that the Earth is free falling in a straight path through the bending and warping of space-time, and Newtonian mechanics was wrong, and that is required to explain it. And then the actual measurement that was received had to be an instrumental error. And Einstein said, if it's not, then relativity is wrong, and it collapses like a house of cards. Okay, so we're going to run through these, but this is them explaining. This is another quote explaining that, well, one option of Michelson-Morley was that the Earth's not moving through space. Objectively, that was one of the options. Edward Morley, Albert Michelson, Albert Einstein, Arthur Eddington, every physicist knew it. Hendrik Lorentz, they all knew that one of the answers was that the Earth is not moving, because that's what we would expect if it wasn't moving. Here's Arthur Eddington saying that you have to actually claim the apparatus contracted to explain it, meaning there should have been a measurement, but the apparatus contracted just the right amount to make it look like the Earth's not moving. So, long story short,
the physical fucking thing contracted. Oh my God. Anything but being a globe. Anything to make it be a globe. Physical objects are contracting in fucking size because of falling in a straight line that looks like a curve. Mind wizardry. These fucking people, man.
This is him explaining it. We can go through this later if we have to, but here I'm explaining that if it's not instrumental error, relativity is wrong. And here he is saying it again 4 years later. This is really grossly misrepresented, so I threw this in here. This is all the replications since then that have shown the same results. That it is an instrumental error, and it's been consistently measured. In fact, the fringe shift changes with altitude. It changes with the periodicity of the sun and the moon, and the solar motion, meaning it changes throughout the year. So,
hang on, I'm going to get us a little bit better here. Hang on.
So, the actual sky dictates what your interference pattern is. This is a major problem because the globe claims that there should be no interference pattern because you can't detect the orbit of the Earth. So that actually refutes heliocentrism on space right there. And this is Einstein saying everything occurs on the Earth as if the Earth's in a state of rest. So as long as we can be on the same page, there's a belief that the Earth is actually orbiting around the sun, but you can't verify it. You can't prove it. Everything's going to happen on the Earth as if the Earth is in a state of rest. There's a kinematic equivalence, means any motion you see in the sky could equally be explained if
Yep.
the Earth is stationary, and that's what the model says. Anyone representing the model that says anything other than that are misrepresenting the model and not being honest. So, and then of course, the rotational claim we can get into as well, but the pendulum doesn't work, the ring laser gyro doesn't work, and we can get into specifics of that. So, motion's never been truly verified other than reifying it and begging the question. And of course, the big one here is that the Earth is a sphere with a radius of 3,959 miles, means that it's curving at a certain rate. I think I am like 5 minutes in. So if you have the radius value here, and everyone knows what that is, the distance from the center of a circle or a sphere, then the Earth's going to curve at a certain rate. And for intents and purposes, up to about 1,000 miles, that's roughly 7.98 inches per mile squared. It actually gives the globe the benefit of the doubt. Actually predicts less curvature than the globe actually does. So that is beneficial to the globe proponents if we're trying to see if there is curvature for all observations under 1,000 miles. Now, what we know in reality is that the horizon is not a physical place.
See, because that's very, very, you have to understand, as you increase or decrease the size of a sphere, okay, the volume increases or decreases exponentially. Now, why is this important? Because all of their fucking calculation of the Earth's mass and thereby, I guess, its weight and going around the sun, all of the orbital mechanics and shit is all cattywonk now. So it requires that. So if we do see a measurement, or we can find a measurement that disproves that specific size, then what's that mean? It's devastating to the whole fucking thing. It's completely devastating. Einstein, Freud, agents, period, leading the people astray. Absolutely, I believe that 100%. Then it was both weird perverts, both of them. I mean, this guy, Freud, it was very obvious that he was infatuated with his dick and his mother. And he tried to put that through projection on other people.
And the way this all started was we were told boats disappear over the curve of the Earth. That's how we know the Earth's a ball. Then we went out and we found out that no, the boat looks like it disappears, but when I pull out optics, I can see the boat again. So guess what they did? They moved the goalpost and said, but no, eventually you can't bring it back. Well, yeah, you're changing what you said. So let's start with step one. Definitively, you can prove that the boat appears to disappear, but actually you can bring it back. It's not because of the curve of the Earth. So therefore, boats can disappear in the distance despite it not being curve of the Earth. Now the horizon moves around. It's not actual. It's just where we got the word horizon was horizontal. It's a vanishing point in the distance. Everything in the sky converges down. The ground converges up. A basic perspective, we see that the horizon is an optical diffraction limit based on our angular resolution, and it's just an optical place in the distance. And it changes based on atmospheric conditions, etc. This is very interesting. So if you actually look at the angular resolution limit of the human eye being about 1 arc minute, right, which is approximately between 0.02 and 0.03 degrees, then it gives you an angle of exactly 0.0217062 degrees of the human eye. When you take the angular resolution limit of the human eye and you actually multiply it by a certain wavelength of the typical conditions assumed of visible light, you can actually end up getting the exact radius of the Earth. So where things would fall below the resolution limit of the human eye, roughly 3 miles for a 6-foot observer, is exactly where the globe claims that the curvature of the Earth would start obstructing things. If you actually look at the math, it's exactly the same. And if you look right here, we have the equation on one of these pages. Oh, it's actually being hidden here. But it actually gives you, if you do the math and you assume spherical geometry is blocking it in the distance, it gives you 3,958.8 miles. And in fact, it matches up to like 10 decimal places, the exact supposed radius of the Earth. What a coincidence. Angular resolution limit of the eye can literally be reverse engineered, assuming the Earth's a sphere causing things to be obstructed, and you get the exact radius value, 3,958.8. That's
damning. That is damning. Reverse engineer using ocular limitations. Yeah. Perfect. That's what I've said all along, but he's got it right down to the numbers.
Coincidence. If you're a globe earther, that's a coincidence. So anyway, we could get into that if we need to. and then I'm going to run through. I think I have like a couple minutes left. We'll run through some basic evidences. So
Minute and
all
a half.
minute and a half. All engineering uses plane survey, which is neglects any notion of a curvature up to 100 square miles. Then we do it in segments. That's 66 feet in each direction of curvature. Yet we have to assume the Earth is flat to actually build things. So when people say still no flat Earth evidence right after this presentation concludes, they would be neglecting all actual engineering in the real world. Specular reflections require a flat surface. You can't replicate one without one. If
Martin, he says, long live Bundy. Al, that is, not Ted. But you got to consider, man, Ted was quite, he was a ladies' man, you know? He was a ladies' man.
water was convex or concave, you wouldn't have that because you would have a diffused reflection. We have them over dozens of miles. Here's the horizon constantly moving, proving that it's optical. We have long distance laser tests. And here is a very interesting one. See what GlobeFace says about this. So on a globe, the horizon is going down and away from your feet in all directions. It's a globe. But as we increase in altitude, the horizon rises with us. So as I get higher, the ground should be getting further and further away from my feet, down and away from me. On a plane Earth, it would rise with us. And that's quite literally what we see. So see if they get that right. And then I'm just going to wrap it up. We have long distance mirror flashes, radio waves. We could get into all the specifics later, but we have many different tests that have falsified the curvature of the Earth. If the surface of the Earth is not curving anywhere, what is it? So what we're left with is a stationary topographical
10
plane.
seconds.
And yeah, so the empirical evidence requirement is on those making the claim that all of that's just an illusion. And actually, the Earth is the exact opposite of what we see and use it as. So that's the burden of proof.
All right. Thank you so much for that there. And we will thank Austin for his opening statement there. Just remind everybody once again, we are going to be doing super chats at the end of our discussion. So if you have questions for either of our speakers, the earlier you get them in, the sooner they're going to be asked. So 10 minutes on the floor. Over to you, Globey. And thank you so much for being here.
Sure. Thank you. All right, let me share my screen.
Ready when you are. All right, 10 minutes starting now.
All right, so we just listened to 10 minutes of zero flat Earth proof, which was expected.
Oh, right off with a zinger. I just wanted to give a shout out real quick to my handler back here. He's been replaced now. We have Something Wong is back. I know what you're thinking. It looks like the same guy. It's because you're racist. That's why you think that.
But here we go. We can actually demonstrate the Earth's curvature and measure it instead of talking about trying to falsify things like relativity and showing incorrect videos with drones flying that are not level. How do you know that drone was level? But we can get into that. We're talking about globe proof. We can look at very simple things that prove the globe. For example, 24-hour Antarctic sun for 4 months out of the year. Well, up to 6, depending on where you are. Impossible on a flat Earth for very obvious reasons. Now, flat earthers have just said, nah, these are all fake, and come up with various reasons to claim they're fake, all of which have no bearing at all. And we can go through those one by one, if you guys like. Star trails, very simple second proof of the globe. Everyone in the southern hemisphere sees the same star trails looking south.
No, it was Howard. Howard was his name. And they're a classic textbook Freud guy, right?
Around the central point of rotation called Sigma Octantis is the star closest to the center of that rotation. Doesn't matter where you are. I've done this observation myself on TikTok with 2 live observers, one in Australia, one in South Africa, both looking south-southwest on their compass at the same exact moment in time and looking at the Southern Cross in the sky. Taking into account magnetic declination, those kind of things. This is over 90 degrees of difference on the flat Earth map, looking, this way and looking this way.
Real quick, off topic just a bit, Mandela wise. Okay, so the guy that used to play, does everybody remember the show WKRP in Cincinnati? Right? And there was a guy on there that he played Johnny Fever. Okay. Who knows who that actor was? Howard what? What was his last name? Starts with an H. If you could put that in the chat, I'd be real curious to see what you come up with.
So declination doesn't really make up for that. It's about a 10-degree difference. So that's not an answer to this. This is impossible on flat Earth without invoking some sort of magic. Okay. Where it does work is on the globe, because again, everyone in the south right here is looking south towards the center point of rotation. Now, why are there 2 points of central rotation in the sky? I don't know, maybe because we have an axis. And those 2 points are directly over those axes, the center of axis of rotation. Okay. No explanation for this on flat Earth. Another simple one, sunsets. The sun sets at an angle to the south from your right shoulder to your left shoulder when you're staring west at the sunset. It sets to the south everywhere south of the equator. It sets straight up and down at the equator and sets to the right or to the north of the equator. Doesn't matter what time of year, doesn't matter where the sun is relative to the observer, whether it's north of them or south of them. If you're south of the equator, the sun sets to the left. Now, I don't think I have to explain why that's impossible on a flat Earth, but the sun circles counterclockwise here. It could never, say from Africa here or South America, it could never appear to be setting down towards the ice wall. It's impossible. Again, it doesn't matter where the sun is, north or south of you. Then we have things like southern flights, direct flights. Qantas 64, for example, that flies direct from Johannesburg to Sydney, 12-hour flight. That would be the flight path here. Even if you made it a straight line, which it's not because it flies out over the ocean, it's at least double the distance of this flight here, which is American Airlines 52 flight from Miami to Tel Aviv. Yet they're the same distance and flight time. Now, flat earthers will invoke magical air currents that whisk the plane faster one way versus the other, yet they fly the same path there and back. So now you're going to say that
magical air currents? There's nothing magical about them. They exist. We can show they exist. They go different directions at different altitudes. What the fuck are you talking about, bro?
The air currents have to be flipping over the same point of the earth to try to make the plane fly faster one way or the other.
I think this guy just graduated from Facebook debating, to tell you the truth. I really do, Shawnee. I think he graduated from Facebook, because I'll tell you what, man, I hadn't fucked around over there in a while. And then I went over there and it's like, boy, are they ever the low level fucking Globers over there, bro. They're like the bottom of the barrel, not got shit. But, really none of them do.
It's absolute nonsense. There's many examples like this where, as you would expect on a globe, it's symmetrical, right? These are at the same latitude, north and south, these two flights. You would expect them to be symmetrical. You would expect them to be the same distance in time. You would expect all that. And that's what happens in reality. Yet flat earthers have to invoke some magic that doesn't exist and they can't prove. Okay. Time check.
Yeah, right now you're at 5.5.
All right. And last but not least, we're going to look at some Earth curve measurements. Okay, because why look at anything else if you can just actually measure Earth's curvature? So we can use things called reciprocal zenith angles, which is this picture here on the right, in which case you have a measuring device here, a theodolite, and a target on the other side. This is what it would look like on a globe, obviously. This angle here, A and B, would be something more than 90 degrees, and that's what we would expect on a globe. If this was flat, which you'd have to visualize, I don't have a picture for you, but those angles would be 90 degrees. So you can do this test over and over again, various locations, test it repeatedly, different weather, different locations, and measure these angles. and they should be 90 degrees on a flat Earth. Turns out they are never 90 degrees. They're always over 90 degrees. Okay, we have this example right here, which is done by surveyor Jesse Kozlowski, and it measured 1 minute and 12 seconds of angle between the observer and the target over 7,300 feet. Okay. I'm sorry, it measured 1 minute 7 seconds. The expected measurement was 1 minute 12 seconds, according to the globe math at the current accepted radius of Earth. Okay. So he got very close, even considering refraction, which it's only just over a mile. Not going to be much refraction there, but if you include refraction, you're still within that margin of error here. And this can be done over and over again. There's a few examples here from Baron Rutledge, who does this all the time live. He's on TikTok. He shows these measurements. He shows them setting it up. He shows everything.
Once they get out of the initial presentations, that's when it starts getting really interesting. I agree. Most people here will agree that this is like, what the fuck do you think? You know, dude, 2018 called and they want their fucking globe facts back. You know, it's like, get a new fucking show or something, but you'll see what happens here. Yeah, I know. So I agree, Shawnee.
Right.
Hang in there, though.
Live. So this is an excellent way to go through it and actually just measure the curvature of the Earth yourself instead of claiming it's flat. Now, what flat earthers won't do is ever show a measurement of anything being flat. They just try to discredit the globe model, which never works, but they try to discredit the globe model, but they'll never actually just go and measure anything. And no laser tests over Laker is not measuring something. That's a laser test. That's light. Okay. And nothing was ever measured in those tests. So I would love to see a measurement of flat Earth. Here's another one from, let's see. Well, here's some laser test pictures from FE Core. I just threw these in here to show why laser tests are inaccurate. You can see that bending light there. Lasers refract just like any other light. So that needs to be taken into account, which it never was in the FE Core demonstrations. And they show things like this, which they claim proves flat Earth, yet they don't show the non-distorted image like this on the right, right? And look at these cranes over here. They look like a funhouse mirror, right? Obviously, there's heavy refraction going on there, but they'll never show you the clear observation day like this. Here's the measurement I skipped. It was the main surveyor. You can go check out his stuff. It's very good. Here you can say, I just show you that there's a link to the full YouTube video of him doing it, but the result was 180 degrees, 17 minutes. I'm sorry, 17.1 seconds. So this was, again, over 180 degrees, which proves that there is a tilt between those two objects. Okay. And this can be done repeatedly and consistently. Okay. There is no flat Earth evidence in conclusion. Thank you.
All right. Well, with that, we will kick it an open discussion, and we will move into muted back and forth if we get too much crosstalk, because we know this is going to be an exciting one. So if you're hanging out in the live chat, smack that like button like it owes you money, because we appreciate it when you guys beat it around. That's really awesome.
So
big thanks to all of our blogs
like
in the chat right now. We also really appreciate you guys and your efforts. So let's get into open discussion. Over to you, Austin. Let's kick it.
Okay. Yeah. First of all, it's funny, the laser you showed, the lights bending up, and actually FE Core counted for the refractive index and knew it was going to be bending up and specifically predicted it based on the index and then observed it. But you guys need to claim that it's bending down and going around the Earth. But whatever. I think this is the bigger part to talk about, Rafes. You say they never show any measurements. Did you miss the part where like all engineering use plane survey measurements? Would you agree that we use plane survey measurements as if the Earth is flat?
No, I disagree.
Go ahead.
In fact, Baron Rutledge is a surveyor. He's a land surveyor, and he shows exactly how he's calculating all these things. And he does not assume a flat Earth in the calculations. So saying they're assuming flat Earth in these calculations is absolutely nonsense.
So plane surveying doesn't treat the Earth like it's flat. It actually accounts for curvature.
Why isn't it called curve surveying then? Why is it called plane surveying? Right? Think about it. Jesus Christ.
Basic formulas account for curvature. And even if it didn't, That's still not a measurement of flatness. That's assuming over short distances that something is negligible. Okay. I know what you're trying to say, right? But why does geodetic surveying take into account curvature in everything they do, right?
Wait, you're diverting away. So first you made the claim that there are no flat earth measurements, because it sounds good. You guys always say that, but there specifically are. All engineering uses plane survey, and I can read it right here. Quote, plane.
What the fuck is a flat earth measurement anyways? Okay. Flat is level. Level's not really, it's a measurement, but it's either level or it's not. Okay. It's kind of Boolean in that respect. So what was that idiot Martin that was on here that night? You know, well, what is your flat earth physics? And so what the fuck do you mean flat earth physics? Physics is physics. You know, is there some other, you know, what the fuck is going on with that thinking? And this, you know, what are your flat earth measurements? What the fuck? It's level. There it is. Boom. Where's your curve measurements? You know, where's your actual measurements?
Plane surveying is a survey in which the Earth's surface is assumed to be a plane and curvature of the Earth is ignored.
Yeah, you're
Now,
reading
this is used for up to
talking
100
point off Google. Okay, that's not a source.
What? This is
Yeah, it's not a source. I will
civil
put you on-
engineering textbook.
Really? What is the civil engineering textbook? Because I can pull you up a leveling surveying manual right now that tells differently.
All right, so it's a civil engineering textbook, and we're like 4 sources on here. I'll show it. I'll link it. But this is what's so funny. This is obvious. Your model claims like, oh, the curvature is so small that it's basically negligible. So when
short distances.
you look over long distances and assume that there's curvature, right, by actually cherry picking the data and then accounting for refraction and changing the R value, that is a measurement. But when it's more accurate at shorter distances using the exact same method, that is not a measurement. Is that correct? That's what you just said, right?
How is it more accurate at shorter distances? Why would that be a thing?
Because the accuracy of like a theodolite is much more accurate at shorter distances. This is why when we build,
Where's your hang up? What's got you hung up, John Fiver? What part of this has got you hung up? I mean, it's pretty basic, really. But let me know and I can address it. Why do you think that you live on a globe? Why do you think that you live on a globe that's whirling around, flying through a void? That'd be my first question to you, Josh. Just put it in there.
things, we build them in small, like 100 to 200 feet increments of measurements because it ensures accuracy.
You're
Because as you
making those
increase
measurements.
turbulence of the medium in different types of conditions, right? The longer distance, you have to account for that more. That's why when they actually build things, they measure it in very small increments. So it's well known, and every surveyor will tell you that obviously the shorter increment measurements are the most accurate ones.
That's because as you get further away, the curvature becomes more pronounced.
No, you just said, why would it be more accurate?
What? Yes. So what's your point?
So you can see that the shorter measurements are more accurate.
Yes, shorter measurements are always more accurate, especially
Then
when
why
you're
do you
talking
say
about
why
the
would they be
globe.
more? Why do you say why would they be more accurate? And
Please answer the question. Why over longer distances do we use geodetic surveying?
oh, because people assume the Earth's a sphere.
It's assumptions. So when they build long distance things, we just have to assume things are curving to get them right.
What long distance thing did they ever build that is assuming any curvature? Perhaps we should see about that that wall city thing that they're going to build over in Saudi Arabia, I guess it is. This guy's going to build this city inside of a big, huge wall. It's going to be 100 miles long or some shit. How much Earth curvature, I wonder, are they taking into account for that? None. Guaranteed.
Right.
Nope.
Like long distance tunnels.
No. So even when we build
Yes.
bridges, tunnels, all of that for all engineering, for 100 square miles,
Bridges are known to be diverting from each other, the towers. So that's a non-point. Again,
are you okay? So we use plane
I'm
survey.
okay. You're making things up. The towers of the Verrazano Bridge, for example, divert away from each other
Yeah.
measurably.
And
The same
yeah.
way I just showed you the measurements of these theodolites diverting away from each other.
because of tension and the amount of diversion in the bridge is nowhere close to what the curvature of the earth would be. The fact you guys still run around saying that the like 3 millimeters of diversion is earth curvature is pretty funny. You guys didn't just go do the math and prove that has nothing to do with earth curvature. It's based on the actual structural integrity of the bridge and the tension, but you're running away.
Please show me
I
your,
want you to
show me your
acknowledge-
reference on that.
I want you to
Please
acknowledge.
show me your reference on that.
Wait up. I want you to acknowledge we absolutely do have flat earth measurements because
you
we
don't.
measure plane survey measures the earth as if it's flat for
That's not
engineering
a flat
up
earth
to
measurement. That's an
No,
assumption because over a
Just
certain
one
amount
second,
of
Austin, just because yeah, you have had the floor for a little bit here, so let's let Globy have a chance here to respond.
he just interrupted me.
over a certain distance, shorter distances, there are assumptions you can make that Earth, when I'm building a deck, I don't need to include the Earth's curve measurements. It's irrelevant at that distance. Okay.
Okay.
But
So
if you were to actually measure it, you could measure it. For example, the example I just showed you, right? That was 7,000 feet. That was a little over a mile. Okay. That measured 1 minute and 7 seconds of arc. Do you know how small that is?
Yeah, I understand your.
I'm not sure you do, Boston.
Yeah,
Uh,
but you're.
You wouldn't need to account for 1 minute and 7 seconds of arc when you're building a deck at your house or a building.
That's what you say, but over
not
10
what I say.
miles, over
Got
10
Austin's one
miles,
as well.
over
Go ahead.
10 miles, obviously it's going to be important, certainly when it's 100 square miles, which means 10 miles in each direction from where you're starting. So that would be significant feet of curvature drop that you
Sure.
completely neglect in reality, according to all plane survey and engineering documents, textbooks, and even government documents talking about engineering. This is basic stuff. So
Yep.
all engineering up to 100 square miles completely neglects the notion that the earth is curving and uses plane survey. That would be flat earth measurements if you're claiming that you can use the same instrument way further outside of the accuracy range and then somehow that's a curved earth measurement, right?
Right. It's that's why they don't take the measurements over that distance. It's not because of earth curvature or anything else like that, or they'd be able to incorporate that into the survey. It's plane surveying. Okay. So they stitch this plane surveying together into a big picture. Okay, basically. And then they do spherical geometry to it. Nobody's building a bridge over a fucking 200 miles long or anything else like that. I mean, they've got some that are really long, but I mean, none of them are taking into curvature. None of them are taking into account any curvature for that. If you do happen to see a bridge that has an arch to it, that's not due to any kind of curvature of the earth. That's structural integrity. The arch is the most it's the strongest architectural. Well, that's where the word architecture is derived from, the word arch, the use of putting arches together. And you can see a lot of this in some of these old cathedrals and shit, where there are several arches that converge together and build off of each other. It's a very, very strong architectural structure. And so you'll see bridges a lot of times, if it's not incorporated in the very top of it, you'll see that arch work in the underside of it, if not even done with straight lines to produce an arch. That's the only time that you're going to need anything like that.
Right.
Why
So
is-
stop saying that.
Why is it outside of the accuracy range? What are you talking about?
We just covered that it's way more accurate at shorter distance, and you conceded to that, right?
Depends on what you're measuring. This theodolite in this observation here was a T2 Herrenberg, and it's accurate up to 20 miles.
Up to 20 miles. Okay.
Wait. Did you or did you not agree that shorter measurements are more accurate?
You're just conflating the issue now. This theodolite is accurate up to 20 miles.
Okay. That's
Okay.
this
So-
is what's a fact, right? Say with your reciprocal zenith angle, since you obviously won't concede that we do have flat earth measurements objectively because we have
You don't.
all geodetic surveying. What it does is it takes the plane survey data and it stitches it together to get the distances in the first place. And then they look out over distances and make separate measurements, assuming the Earth's a curved surface, right? And then they apply a curvature to it. This is a fact. The way we have distances is plain survey measurements. We don't measure distances with geodetic surveying. We
Austin,
actually use the
this-
plain survey data, we stitch it together, and then you guys go out there and use geodetic surveying, right? Assuming it's a sphere. And then what you have to do is cherry pick the data, use a weighted mean within a certain threshold of a predetermined window. Then you weight the mean, you assume a refraction value. The guy you invoked, Jesse Kowalski or whatever his name is, I debated him and he admitted to me that if he didn't cherry pick the data, his R value would have been way too big.
Guarantee he didn't admit anything of the sort to you. But anyway,
He literally did.
can you explain to me how we measure these things over these distances, and why are we measuring these drops over these distances?
Okay, sure.
And
So-
why do they match? Why do they match the curve of the Earth?
They don't. So this is what's also
don't.
very funny about it. So when you actually look into reciprocal zenith angles, they almost never match the actual claimed divergence of the globe. And if they're on a small distance, right, it's barely any. And then they claim that refraction messes with it. And I've heard people try to say that refraction doesn't, but I have the Journal of Geophysical Research right here, 2010, talking about how the vertical temperature gradients between 0.5 and 0.1 km during the day and 1 to 2 km shortly after sunset, that it reduces the variability of K to the range of -2 to +5. Our results show that frequently used Gaussian refraction coefficient of plus 0.13 is not suited for describing refraction effects in the lower atmosphere. That specifically, the reciprocal zenith angles are affected by refraction. Of course, you're hijacking optics, and it doesn't actually match the globe. You have to add refraction and say, well, it's close enough. This is the globe Earth still, man. And then I'll let you go. It is, well, yeah, but it shouldn't be diverging at all. Sure, it doesn't actually match the globe exactly, but it shouldn't be diverging at all. So you agree it doesn't actually match the globe, right? Like you have to doctor it and take weighted means. And
I agree. You're telling me what I agree on.
I'm asking.
Sorry, I'm just eating some word salad here.
Oh, eating some of my word salad here. See, this guy's already a fucking dick. All right. And this is what I say. Okay, when somebody says, "Oh, he uses word salad," dude, that just means you didn't understand what he said. Don't feel bad, man. Sometimes I don't either, man. I have to back it up and go, "What the fuck?" Oh, okay, I get it now. Break down the words. Wait, exactly what's that mean? What's that mean? How can I explain that to my people in a more generalized fashion, so that next time they hear that, they know exactly what the fuck it means, right?
Name one thing I said that was word salad. Can you define word salad?
When you just say random words that don't mean anything because you're reading them on the screen and don't understand what you're saying.
You just made up a new definition of word salad? So can you, what specifically did I
It's when
say
you
that
make
was
up words and put them all together and make them sound like something.
But word salad's incoherent rambling that doesn't have any meaning.
Yeah. Can you explain what you just said then in simple terms for all of us?
Yeah, I did already. There's refraction.
No, you didn't.
that
You
takes-
read off you read off your screen. Can you explain?
There's
it to us?
both. No, I explained it. There's both vertical and lateral refraction that happens in the atmosphere, admittedly, right? Even accounting, you have to account for these in your reciprocal zenith angles. I talked to Jesse specifically about the measurements you're invoking. I debated him about them. He admitted that you have to account for refraction. He said that when you account for refraction and you take a predetermined window, so any measurement that falls outside of that, you don't count them. Then you add a weighted mean to what you do take the measurements down as. So you're cherry picking. You're already cherry picking just the window you presuppose the globe would predict. Then you're going to put a weighted mean. So the closest to the globe prediction gets the highest weight, right? The most weight to get your average. Then you account for refraction. And he said if you get within like 80, 85%, it's considered a success. I asked him then, what would happen if you didn't throw out the other measurements? He said, oh, the radius value you would get would be way too big. So that is objectively what they do, right? So that's just begging the question, reifying the globe model, many other things. It's cherry
So if they
picking.
get within 88% of the accuracy that they expected, they accepted. That's what you're saying?
They have to fluctuate it by 15 to 20% on average after throwing out most of the measurements, and then they get within 85%.
Oh, they throw out most of the measurements. That's weird because he showed all of his measurements.
No, he specifically explains that he writes down the ones within his predetermined window and assumes error or extreme conditions if it falls outside that window. That's just what they do, man.
That's it. There's no need to come on here and lie like this. It's really,
That's all
it's
you got
really
is just to
kinda sad.
claim I'm lying.
I know. That's what they always. You're lying. The fuck, dude. You can tell he's nervous as a whore in church. Though, look at how you can't sit still.
Okay, so
Yeah, you're claiming what you're claiming is all land surveyors are taking measurements, and then most of them are flat, and some of them don't make sense, and they just throw everything out and go, "Yeah, I like these three. These three work. I'm going to use those."
no, let me help you out here, man.
Earth's a
They-
globe.
They assume the Earth's a globe. They don't think they're doing anything other than trying to go out and make more accurate measurements of the globe they think they live on. We have a predicted range of where the measurement should be if we are on a globe, right? We have a predicted value for standard refraction. We go out there, we make our measurements, and then sometimes they fall outside of that predetermined window. It's called a tolerance. They just assume, they throw those out and assume there's some type of either user error or extreme conditions, because we know that based on the globe and standard conditions, it has to fit within this window. Okay. So they cherry pick that specific portion. And he told me if he didn't do that, the R value would be way too big. He point blank explained that.
You know what's weird though? I've watched land surveyors do it live on TikTok. Barron does it live on TikTok. And guess what he's never done? Thrown out observations like you're talking about.
Really? So he went out there and made a measurement live on TikTok and it immediately matched the globe. That's your claim?
Yeah.
Really? What was the refraction he accounted for?
Standard atmospheric refraction.
So
We're only
standard
talking about
atmosphere.
a few thousand feet.
See, you see the point though, is that a few thousand feet, it's not much divergence.
Yeah,
Make
there's
sure
not gonna
that
be
the
much
audience
refraction.
understands what, make sure the audience knows what we're talking about. If you're on a globe that's
Yes. My wife just texted me. She's from downstairs. She messaged me with a screenshot from the TV. She was watching some show and it had Howard Hessman and it was spelled Hessseman. And she goes, "Do you remember his name being spelled?" She goes, How is this guy? And she showed a picture. What's his last name? And I put Hessman, Hessman. And now apparently it's got an E in it. How are we doing on that? Let me see what most of you remember. Let's take a look here. Yeah, it's 69% remember it the way that I do. I think the first time I really became aware of him was a television show called WKRP in Cincinnati. There you go. There you go, Greg. Measures distance and measures angles. So yeah, that's interesting. We'll leave that up for a little bit ago. That's only 26 people. If you haven't voted in the poll, we're just trying to find out, man, because I think this is another Mandela effect, man. We'll run it by the Godfather, Howard. You know what I'm saying? We'll run it by Brian Staveley, see what he's got to say about it, and hopefully, maybe it's someone he already knows about. I don't know. He's pretty big in the loop, man. So we'll find out. I'll run it by him.
25,000 miles in circumference, right? And then you drop a plumb line, which is just a vertical plumb bob on the Earth, right? On a flat Earth, it's perpendicular to the plane Earth. On the globe Earth, you can treat it like it's perpendicular to the plane Earth, but it's just a tangent and it's down relative to the center of mass. So as you increase distance away, they'll start diverging out on a globe. At 2,000 feet, that's basically nothing. That means it would basically diverge out like nothing.
Like
Right.
nothing. Like what's the measurement on nothing?
Just an incredibly small amount. It's an
But you know what we're talking about here, right? So what's the amount?
incredibly small.
Okay, incredibly small. Okay, so it's so
It's
small
common
you can't
sense.
measure it, is what you're saying.
No.
Common
You
sense.
you could attempt to measure it, but it's known that refraction is so much stronger of a variable within that that's a fact.
Within
I just
1,000
had-
feet, within 2,000 feet, refraction is almost negligible.
No, it's not, dude.
Yes,
It's
it
at-
is.
Okay, so I guess that this Journal of
If you
Geophysics
Go
is
to Walter
wrong.
Bislin's calculator and put in 7,300 feet and put in standard atmospheric refraction and see what it gives you.
The Journal of Geophysics is wrong. So this is the truth of reciprocal zenith angle measurements, is that they don't
Mhm.
ever actually match exactly what the globe predicts. When you make that small measurements, it's very small amounts, and it's never going to be exactly what the globe predicts, even though it's a very small amount.
Nothing's going to be
Because-
exact.
Okay, but
That's not a
okay,
fair requirement.
No, okay, cool. Now here's the main problem here. This is what you should be saying. But on a flat Earth, they shouldn't diverge at all. If to make the claim that they match the globe, that's not true. You have to cherry pick the data and then weighted mean it based on the presupposed R value. That's how you get your weight that you apply to the measurements. Then you use refraction, you move it around by assuming this is where it should be. This is how far off it is. There must be this much refraction. That's how it
Austin,
works.
How come nobody with a measurement device has gone out and measured this to be flat?
Well, we just talked.
How the fuck do you measure flat? You don't measure flat. I mean, you can test for level. What the fuck are you talking about? I don't understand this guy's vernacular.
Talked about how everyone in the world has actually gone out to measure
No,
the Earth.
I
to be
didn't
flat.
ask you about assumptions. Okay. I'm not talking about surveying assumptions. Why didn't anybody take a device and go measure over a certain distance and say, yep, here's some flat Earth evidence?
We have done that.
Oh my God. Where in the fuck have you been, bro? Don't they have iPads in prison?
Because we know the plane
Where?
survey. We know the plane survey method works
No,
because we use it
that's
for
not what
all
I'm asking.
distances.
You know that's not what I'm asking, Austin.
But you agree it works.
I agree you can assume things are flat over short distances and still build something accurately.
And your
That's not
measurements
what I
work.
asked.
Awesome. And
That's
you
not
need
what
them
I
to,
asked.
you need them for distances.
Everybody knows that's not what I asked, Austin. Why has it never been measured?
It literally has though.
Why haven't you gone and rented a theodolite, gone and done a measurement, and proved the Earth is flat once and for all? Why have you not done it?
Because it's done every day.
No, it's not. You're talking about assumptions.
No, you're assuming that if you increase the distance and assume it's a globe, that somehow proves that it is, but it doesn't. You
You're
claim
saying
that it's
because I can build my deck and not take into account the Earth's curvature, the Earth is flat.
well,
That's
what I'm saying
nonsense.
is,
If you
if
had an
there's
itch-
66 feet of curvature
Mhm.
in all directions, and you just completely neglect it and are able to build canals and runways and bridges and railways, that would be positive evidence towards flat Earth. To say that there's no measurements of flat Earth is ridiculous. Now, what actually
Show
happens
me
at
one. Where
what
is
happens
it?
at greater distances, you hijack perspective. You hijack the way that we see, and you claim it's the Earth curving. And even though it almost never matches the actual globe, you claim it all matches it because you go to
right.
your little website and move a slider around to make it match. And you act like it's scientific or something.
Okay, so there's no actual measurements of flat Earth. That's all I want you to admit. And it seems you've admitted it.
All plane survey measurements ever for all engineering ever.
That's not a measurement.
Plane survey measurements isn't a measurement.
You take a measurement. It's not a measurement of flat Earth. You take a measurement and you assume it's flat.
No, and then it's
Even
accurate.
if they're doing that, that's not a measurement of flat Earth. I
Then
want
it's
to see some
accurate.
data. How come there's no data about measurements of flat Earth anywhere?
No, then the measurements are accurate. You go out and assume a globe Earth and make geodetic measurements. To even do geodetic surveying, you have to use spherical trig, bro. What are you talking about? If you assume it, it doesn't count. Oh, so this is actually a wash. In fact, it's worse for you because
Of course
you're
it's a
making
wash.
because you actually have to assume the Earth is flat to build things, and then what your side does is takes all that data of flat Earth, stitches it together, and then says, "I promise it's not flat anymore." That's a fact. It's
Austin,
just a fact.
if Earth's a globe and you're going to build a long bridge, so for the towers, for example, right? Wouldn't they just need to be plumb to the Earth at both locations?
Well, yes, in reality, they would be
Reality,
parallel. That's what you're
right.
saying.
Well,
Yeah,
no, you would build them plumb to a location. If Earth's flat, they would be parallel. If Earth's not flat, they would be diverging
Sure.
a small bit, right?
yeah.
Okay. So
And
when
we
they-
do that.
And when
That's
they
what we
do diverge, you say, "Nuh-uh."
No, I'm
Not-
saying that
they're
you
not
claim
diverging.
that you claim they diverge, but you don't account for perspective at all.
Perspective. How does perspective make things diverge?
Okay.
Two towers of a bridge.
Okay. So now you're diverting away. So you're saying you made
You
residuals.
diverted. You brought up perspective, not me.
No. You're looking through optics to make your supposed measurements. How is bringing up how you see diverting away?
So when you make measurements, perspective changes the calculation.
Perspective and refraction are automatically
Mm.
included in what we're seeing.
Perspective changes calculations within things like theodolites. Is that what you're saying?
I'm saying you have to actually account for perspective. That's right. And the atmosphere. And this was so funny. Did you understand the part of my presentation where if you take the angular resolution limit of the eye and you reverse engineer it, you get the exact radius value of the
I
globe.
saw you say that, and I'd love for you to run through that math for me.
Okay.
with a
And then you're going to
guarantee.
concede. And then you're going to concede
I'm going to concede. Yeah, I'm going to. What am I going to concede?
that if you
Let's
take
run
the
through it.
actual, if you take the angular resolution limit of the eye,
Mhm.
right, that you can get the radius value of the Earth to the exact decimal place.
Sure. Well, I want to see what you're talking about because it doesn't even make
Okay.
sense.
Okay, but whenever I show you, you're going to say it's just a coincidence.
Well, you're
I'm
welcome
pulling
to,
it up.
You,
I don't
yeah,
know what
we're
you're gonna
welcome to
say.
do screen
Let's see it.
shares. We haven't done too many tonight, and I've gotten used to doing an obscene amount lately. So if you want to do some screen shares and have your references available, that's cool. I've managed to make it so we can see our speakers on screen, so that's really cool. Speaking of our speakers, I will let everybody know that if you're watching this on podcast, our speakers are going to be linked in the description and on our YouTube description. So check them out there if you enjoy what you're hearing from Globy or Witsit. And Witsit's got his share ready there.
God, I
Smack around
know,
that like.
John. I know it's all the fucking time. These guys, they do not understand how foreshortening works. They don't understand what perspective, anything about it. And it's because they've been so fucking immersed into two-dimensional orthogonal geometry that they're lost in this two-dimensional fucking world, man, in their head.
Like button, everybody. Go ahead, Austin.
All right. I'm on the wrong screen, so I'm going to clip. Let me come over here. All right. The angular resolution limit of the human eye is about 1 arc minute, or approximately between 0.02 and 0.03 degrees. Optical information loss occurs when the angular size of an object is smaller than the angular resolution. This angle at 0.0217062 degrees and an assumed light wavelength of 666 nanometers, you can derive the radius of the Earth. If you look here, the horizon gain for a 6-foot observer across that amount of degrees was inverted as height information loss across the same angle. And the two angles were used to construct a sphere or globe with a tilt angle of 0.0434124 degrees, which is just the first amount doubled, right? So then what you would get, this angle represents the 6-foot drop from a 6-foot observer across the average horizon distance of 2.9 miles. The depiction here is the easiest way to understand it. Either A, we're losing information in the distance because the angle of view in relation to the tangent is actually falling below the resolution limit, so you lose resolvable information, or it's doing that at the same exact distance because the Earth is a ball. So what a coincidence that the angular resolution limit of the eye that tells us that we'll lose resolvable information, right, can be used, that same ratio will give you, if converted to assumed spherical physical obstruction, will give you 3,958.8 miles.
I'm sorry.
So-
Did you have something in here that showed us what the calculation of the radius from the angular resolution is?
Yeah, sure. Here you go, right here. So if you look at we just covered the angles, right? You got the angular resolution limit of the eye, right? Okay. So if you look at the formula here, you have quote unquote the way that you would get the radius of the Earth. You assume that the information loss is actually because of a physical obstruction as opposed to resolution. So you would just make that assumption. You would say, for example, you'd go out onto the ocean and say, look, the boats disappear at 3 miles for a 6-foot observer. A, it's because the boat's getting down below the eye's resolvability, or B, because the Earth's a ball and it disappears around 3 miles. Okay. If you assume it's the latter, that it's because the Earth is going behind the curve of the Earth, then you would take the radius of the Earth and you can take distance divided by the tangent times twice the angle, the theta, the viewing angle. Right. And so when you do that, then you now get 2 theta, which is 0.0217062 times 2. So you get 0.43412. The distance equals the distance to the horizon, which is 2.999547. These are the values that come from the eye, the human eye. And then when you wait up. It's so wild to me. I think it's wild. So when you actually take those values and you plug it into that formula, which is right here, again, radius of the Earth equals distance divided by tangent times twice
How did we
theta.
get that formula?
What? Right here?
No, I didn't ask where it came from. How did you get it?
We just covered how we got it. We just covered how we got it. We did though. So,
No, we
so
didn't.
the angular resolution limit of the eye.
Dude, here again, I'm gonna have to tell you one more fucking time, Globy. Jesus Christ, dude. He's not liking this because he thought he's gonna ask for the math and he wouldn't have the math and he could say, okay, there, yeah, blue, phew, right? And so he says, you got the math for that? And he says, yeah, it's right here. And he says, look, it matches up with exactly how the human eye works. Isn't that some fucking shit?
Right?
No, I didn't ask you what the angular resolution is of the eye. How was that formula derived?
Because what that shows you is that the information, meaning the visible light, the information is going to start to fall below resolvability at a certain distance based on a certain height. That's what the angle does, because theta, the viewing angle relative to the information, the distance of the eye, shows you when the information is going to fall below the resolution angle. It's actually based on propagation and reception angles of what you're viewing with billions of points of light or whatever. Nevertheless, if you assume, okay, well, actually the curve of the earth is blocking something, so it's a physical obstruction that causes the loss of information, you can take that same relationship, flip it around, and coincidentally, if you do that, then you will actually get a radius value of 3,958.8078674,061 miles. Now go Google the exact radius of the Earth, and what's going to tell you is 3,958.8. So now this could just be a coincidence, but let's
Maybe
use
it's
our
a
brain.
coincidence. Maybe it's a
Let's use our-
coincidence. Maybe.
I knew you. Okay, it's a coincidence theorist, but let's use our brain for a second. Now, people back in the day, they didn't have very good
Coincidence
optics,
theorist, I
right?
like that.
So they went out there. I'm gonna stop sharing. They went out into, say, look at the boat or whatever, right? And then it disappeared. They're like, man, why does the boat keep disappearing? If they were trying to think about if the Earth was a sphere, they'd be like, the boat's going behind the curve of the Earth, reasonably, right? So they'd be like, well, it pretty consistently disappears around this distance. If you assume it's going behind the curve of the Earth, then you would get that value, because if it was your eyes, right, it would continuously fall below resolvability at that distance, right? And so you'd be like, oh, but you would think that's because of the curve of the Earth. Now, what has happened since then is we pulled out binoculars and telescopes and cameras, and you can bring the boat back. Objectively, I've done it hundreds of times.
You haven't
What-
done that ever.
Oh my God.
I absolutely have done that. If you go out and everyone
Would this motherfucker been in a box his whole life? I mean, how could you call yourself Globy McGlobeface? And that's his full name, Renee. That's what he calls himself, Globy McGlobeface, like some kind of a Happy Meal. All right. So he's Globy McGlobeface, and you've never seen the hundreds and hundreds and hundreds of videos of people bringing shit in after it goes over the curve of the Earth and bring it back into view. Never seen that before. You've never done any such thing, he says. Fuck this guy.
can do this at home.
You've brought it back in past the optical.
Yes, with
yes.
my
Just
of
one
my
second there,
eye.
Austin. Just because you've had the floor for a little bit here, we'll let just a second for Globy to respond here to some of what you shared there in your screen share, and
Yes.
let's carry
fair
on.
enough.
So the angular resolution of your eye, or the optics that you have with your camera, the object could disappear before it's over the horizon. It's just too small to see. That's literally what zoom is, right? It increases everything
Mhm.
so you can see it.
Yeah.
All flat earthers have ever done is zoom back in a boat past that limit of the optics of the camera and go, look, we're bringing it back in over the horizon. What you've never done is start with a boat or a ship that's half hidden, or however much hidden by supposed curvature that we're saying is curvature, and bring that back in. You've never done it. You've never done it with the sun either.
That's what you're claiming. Don't divert to the sun. So what
Same
we
subject.
have, you have to follow the actual argument you're trying to divert with your talking point. But when you go out and you see the boat disappear, this is just a fact, okay? If you go out and you look with your naked eyes, it'll look like the boat disappeared behind the water. And if you pull out a camera, you will see that boat again. Okay. So that
Show
means that means when Aristotle supposedly in 350 BC said he looked at a boat and it went behind the curve of the earth, and he didn't even have a telescope. He had no idea what he was talking about. If he had pulled a camera, I would have saw the boat again. Now, coincidentally, the very distance that it would fall below the resolvability of an average height of a man, 6-foot observer, that's where the radius value comes from. Do you think it's just a coincidence?
No, see, this is what I think. So what he would have seen if the boat was just too far away to see is a boat getting smaller and smaller and smaller until it disappeared because you can't resolve it anymore. Not a boat disappearing bottom up as it gets further away. Now, what I asked you before is where that formula came from, and you couldn't answer that question.
Where does what come from?
That formula.
I just told you where the formula comes
No,
from.
no,
It's
you
based
didn't.
on the
You
observer.
Right.
Described what you think the formula means. I asked you where the formula
Rayleigh's
comes from.
criteria.
Rayleigh's criteria. So show us.
I just did. So look, if we just covered that because I want to get into how you're wrong about
Let's not
other
cover
stuff.
it again, I guess.
I just showed the whole audience. It's simple. It's like the angular resolution limit of the eye, Rayleigh's criteria. So you take the observer's height, and that's going to give you a viewing angle to whatever you're seeing in the distance, and you're able to determine when you're going to have information loss. Coincidentally, what the human eye is, right? The naked eye observer is going to see coincidentally right where the globe predicts it'll start blocking things in the distance.
You keep saying
Your
that,
answer
but that's
should
not
be
what I'm asking.
your answer needs to be that's just a coincidence. And then
I
okay,
didn't say it's a coincidence. I said
did say it was a
I
coincidence.
think you believe something you read without actually vetting it. And I think
Rayleigh's
that's wrong.
criteria, the angular
Not
resolution
Rayleigh's
limit.
criteria.
Are you denying the angular resolution limit of the
He
eye?
applied it to the formula for the radius of Earth. Okay,
I-
with a lot of assumptions, and you just believed it.
Oh, you're not following, man. So what I'm saying is, if
I am
you went into that,
This guy's like does not compute. I mean, I don't think he understood a fucking thing that was being said there. Both times. Okay, so Witzett's gone through this twice now, I think, maybe 3 times.
situation and you assumed that the Earth was blocking things in the distance because it is a globe, right? If you made that assumption, you could then take that same distance and viewing angle, right? And assuming an R value, you would get the exact same R value the globe claims. So it has to say it's just a coincidence that like a 6-foot observer, you have a horizon at 3 miles on a globe. That's coincidentally exactly where you would start to lose resolvable information based on the naked eye on a flat Earth. And this would happen on a flat Earth or a globe Earth, right? We all have eyes. We all have human eyes. So now it would require, okay, and that means when you bring out different optics with more zoom, you'd be able to see further. And of course, that's what happens in
So
reality
let's see some examples of that. We got some examples of that happening.
of us pulling out optics and seeing far further than the naked eye.
Bringing a ship back from over the horizon. So
Okay,
simple. Such a simple claim everybody makes. I'd love to see one finally.
Yeah. So I can't show you a video of my naked eyes, but obviously everyone knows that if you go out, it'll look like I went and tested this claim. You should do that.
Oh, so
If
you're
you've
saying
been-
just
if-
with
if-
your eyes, not with cameras.
Right. So we all agree that at one point, based on the conditions of that day, the boat's going to get to where you can't bring it back anymore.
But you
Everyone
said
agrees with
optics
that.
brings it back. You said modern optics bring them back. That's what I'm
No,
talking
I
about.
said that optics is going to bring it back past the angular resolution limit of the eye.
Right.
Right. And on certain days, you're going to see the boat from way further away. And you
So-
guys will claim that it's refracted up
Well,
right?
so why has a camera never brought a ship back from over the horizon?
because it's into the vanishing point, bro. You lose resolvable.
Point.
You can you can lose resolvable information. So when the camera's zoomed out and then you zoom in, you do see the boat again, right? But once you zoom all the way into the maximum zoom of the camera and then the boat disappears, obviously you can't bring it back again. And this is also going to be
I didn't
based on
say that.
It's going to be based on attenuation. And the globe model claims they don't even account for attenuation and refraction, which is insane. Absolutely insane.
Austin, need to.
Are you following me?
You need to reel it in. You need to reel it in. Your
You're-
claim is you can use
evolving.
optics to bring a ship back from over.
What the fuck part? Once you've reached the limit of the optics, okay, you're fully all the way zoomed in, and then the boat goes on into the horizon. It hasn't gone over a curve. Of course, you can't bring it in. You're at the optical maximum of the lens. Now, using a larger lens, the problem you're going to run into, as he said, attenuation, the light scattering within the moisture particles and every other goddamn thing that's at the lowest extremities of where we're standing, the densest portion of everything. You get a certain amount of opacity that increases over distance. It's just like cloudy water. You can see your hand in front of you in cloudy water. You move it further away, someone swims off. You don't see them anymore. They go off into the murk. Did they disappear? No, not really. They just went into the opacity of the medium. These people, man.
the horizon. Why has that never been done? Simple answer. That's all I'm looking for.
I said it has been done unless it's
Okay,
already
so then prove it.
unless it's already beyond the actual vanishing point at the
I
time.
didn't say anything about beyond vanishing points. Okay, a tanker ship where half the ship's missing. Why has that never been zoomed back in and brought back into view? Are you saying coincidentally everything that's over the horizon is past the convergence point of?
that's what the
That's
horizon
what you're
is?
saying. Oh, okay.
No, that's what the horizon is.
Come on,
So
man. Your claim is that you can bring them back into view. We're zooming them in.
I'm not
You
going to
just
repeat
said
my
it.
claim. The audience heard me say that with the
Yeah.
human eye, it'll look like it disappears. You can pull out cameras. So if I pull out binoculars,
out cameras
check this out. Say I use my human eyes and then the boat disappears. Then I pull out binoculars and I can see the boat again. Then the boat disappears. If I pull out a camera, I can see it again. So as I increase optics, I can see further. Eventually, you
But
can't
at what
see any
point?
further.
At what point in those scenarios was the object ever half hidden? Because I agree with you. You can wait till a boat gets so far away that you just can't see it anymore because it's a small boat and it just disappears. You just can't resolve it anymore. And you could zoom it back in. I agree. But it's never been done with a ship half over the horizon being zoomed back in ever.
Well, once the angular, the apparent size of the object gets smaller than the fucking the mirror line, the horizon line, all that little fuzz that's going on right there at the horizon, of course you're not gonna fucking see it, man. And by the time you zoom through far enough, you can't see jack shit at that distance anyways because of the fucking thickness of the atmos. Look, we got a lookout over here on the Massanutten Mountain. You can get up there and look across the valley. It's beautiful, man. And during the summer, if it's real humid, you can't see for fucking shit. You can barely see across the valley. Whereas when it's drier, you can see way further. Why? Because there's less fucking moisture in the air. Now, when you're over water, do you think there's moisture in the air? Fucking A, right, there is. And where's the highest concentration of moisture in the air? It's going to be right near the surface. Gee, I wonder why. Huh? Maybe it's because water vapor comes from liquid water. Yeah. Duh. Christ.
Ever.
This isn't true either, though, because
It is
now
true.
with the okay, so this is the problem. You would actually have to be able to like record your human eyes, or maybe like record binoculars. That would be a good idea, or just different optics of cameras. That's how you would have to do it. But more importantly, and you can zoom it in. This is the thing, right? There's a few things with things disappearing bottom up over the water. For one, obviously everyone understands the concept of like, if I hold my thumb up right in front of my face, I can block a building, right? Just because of the relative angles. So like if there's any waves in the water, even a small wave close to you in the foreground can block out entire 20-story buildings, right? Now, I'm not saying that's the only thing that does it. I'm just saying that's obviously relevant in over the water things. You guys never even discussed that. You can just block out a building with your thumb and prove it's a very simple concept. And then we also have the reception and propagation angle coming from that object is the smallest in relation to like the eye level at the bottom of the object. So if you account for Rayleigh's criteria, the theta, the viewing angle, is smallest at the bottom of the object. So it falls below the resolution angle first, or the resolution limit. And then you have attenuation being the greatest at the bottom of the atmos. So you would have to see things disappear from the bottom up on a flat Earth.
Oh, morning, fella.
What happened?
What the fuck have you done,
Yeah, I was
Ryan?
gonna say, we're looking at your screen. I had a feeling. I was like, did we lose audio for a second there? We all just went silent.
Oh, sorry. I said, can I share my screen? But
No,
maybe you didn't hear me.
Oh no, that's okay. Yeah.
I want you to take a look at the difference in wave conditions over on Globey's little fucking TikTok video that he made there. Right here, we've got pretty still waters. Right here, look at those fucking white cap waves. When you got white cap waves in the ocean, that's rough seas. Okay. Those are pretty good sized waves, 3-4 foot maybe. Okay. And what did we say about a wave over distance and things in the background? This guy is like intellectually, if he actually thinks that's something, I don't know what to say, man. He's either intellectually dishonest or he's really dumb. One of the two.
Hey, yeah, of course. Your screen is sharing now. So sorry. You're good to go.
This is what, like a 300-foot wind turbine? And you're going to claim a wave is blocking half of it?
Anson, I got a rumor that they're going to be having on Wednesdays. They're going to have Cricket McNuggets for in the cafeteria at the FEMA camps. So yeah, it's going to be pretty good, man. We'll be looking forward to Wednesdays. Have those Cricket McNuggets. They're good shit right there. You're gonna like it. Would you like it?
I said many things.
Or the optical. Yeah, you did say many.
You will eat the burger and you will like it. We have ways to make you like it, you Schweinhund.
Things. None of them apply.
Really, can you still man what I said?
I stopped listening because I was starving from all the.
Yeah.
And I don't want to say the word salad thing.
See, that's what I'm saying. You guys can never actually still man the arguments. It's pretty ridiculous. But the ground, the water is going to appear to ramp up in the distance,
Sure.
right? You obviously have things in the foreground that are going to appear to block out things taller than that in the distance. You have attenuation rate being the greatest at the bottom, and you have the viewing angle of the actual points of light or information coming from, say, the wind turbines in relation to that vanishing point being the shortest at the bottom, the smallest angle at the bottom. So we would have to see them disappear bottom up. And of course, here's a video of a boat, when you zoom out of it, you can see as you start zooming out, the bottom of the boat disappears first as you start zooming out of the boat. So the fact you guys still deny this is wild to me. You want me to show you?
It doesn't happen. Yeah.
Okay, then let me just show you.
And everything you just said was an immense excuse as to why these things are being blocked. Because there's no reason why the angular resolution at the bottom of the thing should be less than the top.
What? It's because do you think that, like, if say there's a boat, do you think it's just one point of light, or do you think it's like millions of different little points of light?
It's the whole thing.
No, it's not. It's millions of different little points of light. So that's what I'm saying. You guys don't even understand.
The whole boat is giving off light, and as it goes away, it's compressing into the distance.
But there's millions of little points of light. So there's a different angle to the bottom of the boat than the top of the boat. Right.
A different angle? Yeah, well, you're 6 feet off the ground, so there's going to be a slight angle change to the bottom of the boat versus the top of the boat.
Okay, and that's
very minuscule.
And doesn't matter. It's that it's going to be smaller at the bottom in relation to the.
No, it isn't, because if it's here, you're looking here at the bottom of the boat. As you're watching it go out, you're looking here. You're looking here over more flatness. When it comes through, your angle of view is going to be different when you're looking at that bottom of that boat, because your horizon's out here.
Horizon, right? Now the horizon is where the ground appears to meet the sky. So the angle, the viewing angle, is going to be smaller in relation to that horizon at the bottom of the boat. It's going to fall below resolution first, meaning it's going to fade into the vanishing point first. It's just a fact. It's on a globe Earth. This also has to be true.
It's not a fact, Austin.
Okay, on a globe Earth, it also has to be true.
No, it doesn't.
Absolutely. But we beat this into the ground. We beat this into the ground. So, like, do you have any? Now, this is my opinion. This is how I actually look at this. Okay. People always say, like, no evidence for flat Earth, right? And like you said that, and people always say, and why do you talk about relativity? Because people are scared to have that conversation, whatever. But don't you agree that, like, on a base level, we experience the Earth, right, as if it's stationary and as if it's a plane, and as if the horizon's horizontal, right? And the globe Earth model says that, well, it's moving, but like its relative motion is so small that you wouldn't be able to tell, right? And that the Earth is so big that you wouldn't be able to tell it's curving. So that means on its face, using Occam's razor, that which requires least amount of assumptions, the Earth's a stationary plane until proven otherwise. So the globe Earth has the burden of proof. And I've never, like, there is no proof. We falsified the globe. So, like, for example, can
As
you
go up
prove
in
that?
altitude, you can see curvature.
No. But can you prove that the Earth is moving?
You can't see curvature when you go up in altitude, or not. We've shown about that. The horizon would drop below you as you go up. It doesn't. You just start seeing more and more and more and more and more and more and more. You're just increasing your angle of view is all, and there's no curvature. This guy's ridiculous.
Rotating, yeah.
How so?
First off, trust your first point. You said you can't see the horizon's horizontal. It is not. As you go up, you can clearly see more and more curve as you go up.
That's what you guys claim, but when we send up lenses that are actually more level, we see that it's flat, 120,000 feet up.
A balloon with a concave horizon because you're using fish eyes.
it goes, it bends every which way. And it's not just fisheye. Rectilinear lenses. I've actually offered each Glober that says this money. See if anyone's going to take the bet.
Sure.
So $1,000 bet that with a rectilinear lens, it still imposes curvature on the image.
I see what it is. These guys have been using a rectal linear lens, and they're getting their information out of their ass. Not a rectilinear. They're using a rectum linear.
Anyone want to take the $1,000 bet? Rectilinear lens still distorts and imposes curvature
small.
on the image.
Very, very, very small. That's the point.
So it does. It does. And then it's gonna increase based on angle of view. And certainly if you compress an image like this guy did with his little balloon. But I just want to point out that like you think we're spinning, tilted, wobbling, flying through space, and you don't have any proof of that. Like, can you explain why you believe it?
You're changing the subject.
Because we've talked about this for the whole time.
We have not talked about Earth, the curvature of Earth as seen from high altitudes at all.
Oh, okay, yeah, whatever.
Right. So, have you seen Kip Dugardas's 300-foot rocket launch?
I wouldn't. No, I don't know.
He used a rectilinear lens, showed the lens, everything, uncut footage all the way up to 300,000 feet.
Was there curvature like 10,000 feet up?
He only went, there's not 10,000. I don't know. You got to watch the video.
I know. I haven't seen it, my brother, right? But rectilinear lenses do impose curvature. But there's a few things that.
But it's curved perfectly. The same rate of curvature when it's low in the screen, middle screen, top of the screen. Doesn't matter where it's showing the horizon. It's the same rate of curvature.
No, it's not.
I've matched it to, Walter Bislin's Earth curve expectations at those altitudes.
Well, you have the first video that's super legit. I guess if you want to send it to me, then I'll check it out. But
we can watch it right now.
Okay, I don't know because I don't want to just watch some long video. You think I'm scared of your video of a rocket?
I just want to hear you say nah to the video.
I already said rectilinear lenses impose curvature based on their angle. If that camera is tilted down at all, it's going to impose a curvature rate proportionate to increase in altitude because it changes your angle of view. These are basic things.
Well, what if the curvature rate is the same throughout the whole video? Then what?
What? How does that change anything?
Because it's not the camera making a flat horizon curved.
So then the camera is not imposing any curvature.
Do you know what happens to the center of the frame of a?
It still can. First of all, how did you know that on the camera on the rocket was perfectly level since we couldn't use the drone?
Doesn't have to be level. It's curved every angle it shows. It's curved. Now your example of the drone that requires the drone to be level. Otherwise, you don't know whether the horizon's rising with your eye or not. That camera could easily be pointing down a little bit as it goes up. So if you're trying to...
At what altitude do we see the curvature in this video?
Oh, we can watch it together.
You don't know though? So just to clarify, like, we're never going to get to we're not going to get to the motion. I mean, we can stick to you claiming that you see it. We can debunk that too.
Listen, motion doesn't prove the shape of the Earth. I know you love to talk about that because you think it invalidates something, but literally you can measure the curve of Earth and you can go up and see the curve.
We've already debunked everything you've said so far.
You have. That's interesting.
Yes. But like you say, I love to talk about that, but no, you believe it. You believe that you're tilted, wobbling, spinning, revolving around the sun. That's a belief that you have, but you don't even
Why don't you want to go see the Earth curvature right now? Why don't you want to go see it?
What do you mean? Why wouldn't I want to go see it?
We can go watch it right now. You want to go see it?
I said I didn't care if you pulled the video up a long time ago.
It's only been an hour. We got tons.
Just to admit that you are clearly scared of the motion argument, though. Just admit that you don't know much about it and you just believe it.
No, I'm not scared of anything.
If you'd like. Sorry.
The topic of the debate is flat versus globe.
Is the globe true? Is the globe true? That's what it is.
And it's not. It's flat versus globe.
Hey, if the surface of the Earth isn't curving anywhere.
One of us can show measurements and video of Earth curvature and measurements of it, and one of us can't.
No, but we debunked all your claims. You've been wrong about basic flat Earth 101 things. You don't even understand angular resolution limit or Rayleigh criteria or relative viewing angles. You thought that the boat was one singular viewing angle.
The Rayleigh criteria was the formula you were showing, and it was not. And I clearly asked you 3 times to derive that formula that you were claiming you understood, and you couldn't do it.
I literally showed it 3 times.
No, you didn't.
I guess this is where this.
Holy shit. This guy is just wanting to pick at some stupid shit that he doesn't have any clue about, man. And I'm glad that the Witsit said it. Somebody had to. We did. This guy's shit is right out of Globe 101 crap, man. This is crazy.
This is what Glober's devolved to, is just like thinking if they recharacterize and revise what happened confidently enough, everyone in the audience will be like, yeah, that's totally what happened.
We
I
all
guess. I
saw
don't know.
you. We all saw
It's
you. avoid the
recorded, my
question, so-
brother. It's recorded.
Yeah, it is recorded.
Okay. And we're gonna talk about how you can't actually verify motion after this.
Sure.
That's what's up.
So I know you love it, and it has nothing.
Yeah,
to do
because
with
I know that
the
you
shape
don't
of the
know
Earth,
about.
But
No, I've already debunked the globe. I said specular reflections are impossible with convexity or concavity because it would cause a diffused reflection. You duck that.
You guys
Long
are
distance, like line
you guys are fucking brutal, man. I swear sometimes, man, you guys soft talking creeper. I love it.
of sight, radio waves and microwaves. You just start making up stories. We said that plane survey measurements are required to build anything in reality. There's all kinds of physical empirical measurements. You showed a laser bending up, and your model claims that it has to be bending down. You thought it was some
No, it
type of
doesn't.
refutation when they accounted for that with refractive index.
Depends
Everything
on
you've
the
said so
atmospheric
far has been
conditions.
wrong, my guy.
Uh-huh.
TikTok's a little bit of a different world, you know. You
Is
can
it?
pick out some random people that don't know what they're
I'm
talking
still
about.
waiting for a measurement of.
No, Mr. Lay, he's eating his he called it word salad. That was going to be his big killer line for tonight because people always say wits that uses word salad, and it's just because they're dumb and don't understand it. Or let me rephrase that. They didn't understand it, and they don't have the fucking will to go look and what did he actually say, try to understand it. So it was words, you know, that have more than 3 syllables, and it just kind of fucks them up. You know what I'm saying?
Flat Earth that you didn't provide,
Except
or
all
an
plane
explanation
survey,
of the formula that you didn't
Night,
provide,
Dreamy.
all plane survey measurements ever.
and you claiming plane surveying somehow disproves the globe.
No, you asked for
That's my favorite.
You asked for measurements of a flat Earth.
Yeah, show me a measment of flat Earth. You still haven't done it. You
Coming
just
up,
claim
machine.
surveying.
All
You
plane
can't-
survey
Someone
measurements
just asked
ever.
for
I wanted to
That's
get
not
into
a
your-
measurement. Nobody here believes
Hey,
that
but
that's a
Globe
measurement.
Face, will you play this? Hurry up, because I want to get through your list of misinformation
Sure.
and your presentation.
I don't think you do, but
I absolutely do.
so here's the camera he used.
Yeah, we'll make ourselves small for now.
I know you say it doesn't matter if it's rectilinear because it just makes everything flat, the globe, but
What? No, it's just a fact. It imposes curvature. And Globers lie about it.
not through center frame. It doesn't, does it?
Yeah, I'm offering money to bet on it.
Nothing through center frame. Doesn't matter what the lens is. Nothing through center frame distorts.
Well, it depends on the actual specific
Look at
viewing
that.
angle.
Doesn't matter what the angle is, as long as
It does,
the
though.
object you're looking at is center frame.
You want to bet?
Yeah.
Okay.
The thing,
what do you want
the
to bet?
thing you're looking at is the thing you're measuring.
So it started showing curvature of the earth lifting up. Come on, man.
If it's center frame, there's no distortion.
So if I
doesn't matter
compress
what
it,
angle.
it'll be completely straight, right?
You can press what? The picture? Why would it be
Picture of
straight?
like a table
Mhm.
in the middle of frame. If I compress it, it'll be completely flat.
Yeah.
No, it won't. And so do you want to bet on it?
With a rectilinear lens?
No, it won't.
Okay, pay attention.
I know that goes against your guys' script, and so you have to just deny it. But I mean, that's why flat earthers
Speaking
exist.
of ner-
Because they find out that what I just said is just a fact, and for some reason you guys have to deny it.
and speaking of moon rocks,
It's not a fact.
speaking of moon rocks, Barbara, I have to conduct another vacuum chamber. See our little Masonic one-eyed NASA experimental beaker. This is what we're using for our pressure tests up here. I'm doing gas pressure experiments. I forgot why, but it doesn't fucking matter. So we're just gonna go, and do it. So this is test number. I don't know. I lost count. So we'll just say 100.
Nuh-uh.
Literally, if
Right.
you have a straight line, if you have a curved line through center frame of a fisheye, it's going to look just as curved as it is in reality. That's a fact of how wide angle lenses work.
Oh, it doesn't look very curved right there. Wait a minute. So as it's going up and
Just fucking breathing, man. Oh, just to let you know. Test results nominal.
down, you can claim that the relative locations look like a curve. I just saw where it looked flat where it slowed down.
That's cool. You want to wait till it stops spinning?
That's hilarious.
because I don't think we want to look at while it's spinning, right?
But how is it? I mean, how does it ever look like it's flat though? I thought you said it never looks like it's flat.
It
I
doesn't
just
look
watched
flat
it look
here
flat.
either.
I just watched it look flat.
Okay, well, I'll fast forward to when it stops spinning, okay? So we can stop looking
See
at
how I
the
can make
spinning
this look like
distortion
it's
being
bending.
created. This is, I don't know, 200,000 feet. 250.
It's always when it starts going down. That it's like, wait, do you think that's how much the Earth curves at 250,000 feet? Run it back. Run it back. Don't get scared now. You brought it up. Oh,
What happened?
you ran away.
Did I? It
Okay.
looks like I'm still here.
I don't think you actually did. Just run it back. We just saw like the
said,
smallest globe in the history of mankind.
Said the Zoom crashed unexpectedly. I don't know, maybe because I'm sharing.
I was trolling you, man.
That's all right.
Of course, the second that I take
Look at this. So look at the rate the Earth has to be curving if that's the
Look at that.
ball
Look at
Earth.
that. That fucking-
250,000 feet?
Mhm.
You think that was like the accurate depiction of curvature of a globe?
Yes,
Okay. So can you
So-
show me the math? Show me the math.
sure.
Yeah, because according to the math, you would not see nearly that much curvature. We have it all like mapped out in Blender and everything.
You wouldn't nearly see that much curvature.
Where it curves all the way around, you basically see the whole ball in that frame, bro. As you keep going down, you see
No,
the
you
whole
don't.
ball Earth.
Barely, it's barely curving.
Watch it. Watch it.
Let me
No,
get,
no,
let me
don't,
get
don't
to the
go away.
apogee. Going
Don't
to the
run away.
apogee.
Don't run away.
Who's
All right,
running
see,
away?
now it's
You're getting to the
curving. It's
highest
curving.
point.
Watch this. Now it's going to start. Look at all that curve. That's the smallest globe Earth ever, bro.
The smallest glow. You just said it was too much curve. Now it's too.
That's
little
what I'm
curve?
saying. It's too much curve because the smaller the ball, the more it curves, right? All right.
There again, I understood what he was saying. This guy, oh, what do you mean? Good gravy.
So
dude.
we can move on. This is terrible. It's based on the relative viewing angle clearly, and that just proves that even the rectilinear
Sure
lens
about that?
drastically and grossly imposed. Look at that. It's always greater curvature when it's going down.
No, it's not.
Oh, what about there? Wait up. Bring it back. Bring it back.
We're going to bring it back to where it's level here.
Oh, what about the other way when
So
it
here
was
we got a nice
showing
clean-
that it was concave?
It wasn't concave. That was the
Then go
side.
back.
It was the side walls of the camera of the housing. There's a point
So
where
this
it
is what.
reflects off
So
the
what
housing.
you've done is you've paused one screen.
I just paused it where it's low in the frame, and I'll do it at the middle and the top.
It's so funny. Okay,
Okay.
so
here's
I'm
the,
gonna
here's the bottom of the
ag-
screen.
Okay, agree to disagree.
Here's the
rectilinear-
bottom. Here's the middle.
Look, the curvature
the
rate's
top.
changing. That's
Now,
crazy.
Yeah. Well, it's
Wow, the Earth is
fluctuating
getting
all over the
smaller and
place.
bigger during this video.
Or maybe you're seeing a little bit more of it in the screen. Now watch.
No, the curvature rate is changing. You specifically claimed that the rate didn't change.
It's
You've
not
been
changing.
debunked. You pulled your own video up and been debunked. Someone's
Yeah, I have to agree, man. We're seeing some different shit here.
gonna clip this up and show that you were just wrong. So, okay,
They
so
can, you can do whatever you want.
all right.
but
Well, we disagree. I
Make
disagree
sure
with you.
when you do that,
We've already pointed out that your claims were wrong about the video. Can we move on to something else?
no, I'm going to prove you're wrong right here.
Oh my gosh. See, you're scared to move on because I think you realize like
No,
you're a
see,
little,
this is the problem with debates.
you're a
when
little
they're
out of your
open,
league,
right?
I think.
If it wasn't open, you'd be able to just move on from this.
You want to talk?
go,
No, I just
"Eh."
pointed out what was wrong with it. Can you still man what I said?
Yeah, you said the rate changed. The rate of
Huh?
curvature changed.
Rate of curvature change. What else did I say?
You said nuh-uh. I
Nope.
believe.
Nope.
Mhm.
So you notice Globers can never still man.
That
Isn't that
light's
crazy?
25
You said it was a
watt bulb,
fisheye lens
too,
being
babe.
curved.
I didn't say
Even if
fisheye
it's
lens ever. That's
rectilinear,
a
you said it
straw
was being
man.
distorted by the lens, is what you said.
Provably so, because the rate changes, and that couldn't
provably
be the
so.
rate of curvature of the globe Earth, because you
Yeah.
see all the way around it from 250,000 feet. You wouldn't be able to see the entire globe. You have to get many, many, many miles out
Wasn't
into
the
space
entire
to
globe.
see the. You just saw it curve all the way back, looped around.
That
My
wasn't the
God.
entire globe. So
Okay.
here-
Okay, cool, man. So I
Yeah,
already
cool, man.
said, I already pointed out what's wrong with it. The curvature rate changes. Rectilinear does impose. You're pulling things below the middle part of the screen anyway. You claimed that it was going to be middle of the screen, that the curvature
There
rate
you
was
go.
never going to change. You skipped past the concave part of it. You skipped past the flat part of it.
Are you going to
You've
keep
been
talking
debunked
through it
live.
at all, or are you going to actually pay attention?
You've been debunked live.
You're literally the definition of nuh-uh right now.
That
So
doesn't
this is-
even match. It
This is
doesn't
the
even match.
expected Yes, it does. This
No, it
one's
doesn't.
tilted
All right,
slightly.
let's let him-
Austin,
Stop.
use your imagination,
your
please.
balloon
Hey,
A
do I
little
have to
bit.
sit here for 30 minutes while he watches a balloon video? Is that what I have to do?
This is
Do
a
I ever get
rocket.
to bring up a topic? You
This is
guys
a
let me
rocket.
know when I can bring up a topic.
What we'll do is just for the sake of what you're asking there is we'll give you a minute there, Globy, to
Okay.
present
No,
what
no,
you got
we're-
here on
we're-
screen.
We're good. We're
And
good.
then, oh, okay, all right. I was just gonna say, just in the interest of moving on and being fair, because you're both kind of getting your chip in here on what we're looking at. So, did you guys want to continue sinking your teeth into this, or did you want to move on?
No,
Already
no, we're
done.
good. I just showed that it matches the observation as expected by Walter Bislin's Arthur calculator. So
Okay, anyone that believes that, I mean, I'll just recap. It clearly showed different rates of curvature, was below the middle screen, rectilinear leans. I offered $1,000 bet anyone in the audience,
Fucking thing looked like it was breathing, man. It looked like the earth was breathing.
even you, if you want to take it, that they absolutely do impose curvature. The rates
Magic
change. We
eight.
showed concave, you
sir.
skip past it. It showed flat, you skip past it. The rate
never showed
changes.
anything concave. Stop lying.
The curvature of the Earth, if that's the globe, would have been way too great at 250,000 feet, where you see it looped all the way back around. Those are my refutations, and
Okay.
everyone that's claiming that that isn't what happened, they're just coping. I don't care. But I want a question now. I got a question now. All right. Can you verify the claim that the Earth is a ball that's spinning?
Spinning.
Yeah.
Sure.
How so?
Ring laser gyroscopes.
Okay. What does that prove?
It proves that we are rotating 15 degrees per
Really?
hour.
How does it work?
Oh no, I'll ask you that question.
You invoked it.
You invoked it. You asked. It's your like point. I know what you were leading to. Don't act like you weren't leading to this. So I want you to explain to me how the Sagnac effect works.
Pretty embarrassing. Pretty embarrassing.
No, I know how the Sagnac effect works. I'm asking you to explain it.
It's your claim.
All right, for our audience, if you can, either of you explain what you're talking about here, just for our audience, that would be great.
It's his claim, Ryan.
Well, yeah, it's my claim. So when I explain to you how it works, you're going to say somehow it's the magic sky making it happen and not the actual device moving.
Just explain how it somehow measured the Earth moving. Can you explain it? Do you understand it, or what?
Yeah, sure.
Thank you.
And then, yeah, and then we'll see the afterwards. So, yeah, for the audience sake,
Googling it.
I can either draw it out or we can just look at a picture of it.
That's embarrassing.
Which part's embarrassing? That you don't know
Are
how
you
this
ever gonna
even works?
Google it?
I'm picking up a picture so I don't have to draw it, Austin.
All right, let's give we'll give Globy a second here, and once again,
Time's
we
up.
will move into Q&A. Probably what we say 10-20 minutes, guys.
Sure.
Cool. All right, I think there's gonna be a lot to dig into there, so get them in and don't let me.
Man, I'll tell you what, I'm glad that NASA provided all these cake up here because I get the munchies doing all this science. I really do.
Interrupt, guys. Let's
Sure.
get
This is
right.
the basics of it here. So we have a light source that shoots a laser one direction and then another direction. And they go around in this loop, bounce off these mirrors, and return back to this detector plate. Okay, now what happens is as this thing is rotating, the light, say it's rotating counterclockwise on the screen here, right? The light going this way, counterclockwise, is going to take slightly longer to hit the detector because the detector is physically moving away from the light source. It's rotating away from it. The light going the other way will get there a little bit sooner. So that creates an interference pattern. It shows different wavelengths of the light on the detector. And we're able to use that to determine which way the device is rotating and how much. Now that's the Sagnac effect. That's the ring laser gyroscope. Thanks, Bob. And that is literally what we use in aircraft now. We use ring laser gyroscopes in aircraft, modern aircraft. There's one in Germany that is in a mountain that they're using every day to measure the Earth's rotation. The most precise measurements ever done using these, I might add. It's a very huge
Come the
device.
fuck on. No, you don't.
By the way, they put it in a mountain to make sure they could isolate it from any potential interference. Yeah, so that's a Sagnac effect. So now this
Also makes it hard to get chapped up on too. Make it more difficult. It's like Santa Claus. He's real, but he lives way up at the North Pole where you can't go. and it's freezing cold, and you'd probably die if you went to go try to see them and shit. So, yeah, that's why they do it in a mountain.
Works because the detector is physically moving away from the light in one direction. Now, go ahead, Austin, and explain to me how this doesn't actually measure Earth's rotation.
Oh, okay. So obviously it is a precise way to measure some type of motion or rotation, right? Interferometry. Yeah. So you're assuming that it's measuring the Earth rotating. Sure. But the problem with that is that we've shown that the measurements change with altitude. So
Do they?
do you agree that if you keep the same latitude, but that it changes with altitude, that would refute the claim that it's a spinning globe that causes it?
If that were true, it would have to be retested, yes, but that would be a problem. Sure.
Yeah. So it has been retested. I won't show just the paper's names, but I can read some of them off. But Demio did it, for example, in like early 2000s. It's been done many times. It changes with altitude. It also can change with solar motion, depending on the precision of the interferometer. So this is Michelson-Gale-Pearson-Sennek effect, right? And it changes with altitude. So
Also, just so y'all know, before I forget, the new Brenda swimsuit calendars are out. I know it's a little late in the year, but you can get them at a discount now. So I know many of you be interested in that. Lots of sexy poses.
So
Have you ordered yours yet, Hanson?
I didn't even know it was available.
Yeah, the new Brenda swimsuit calendar for 2024. You can get them at a discount because February is almost over, but you still get the pinup pictures, so.
Sounds exciting.
I'm going to see how many
trying to find the right adjective, that's, I don't know, man.
I'm waiting to see how many barf emojis come up in the chat after that one. Ow.
Definitely should do the goth theme well.
Like it's not too much on that, Dave. Does that come with the tuck option? Is pitch lumen in it? Oh my God, no. What did I see that I guess Brenda's going to be debating Dustin Nemo, I think, on religion. I'm not sure. I'll check on that here in just a second. I think it's going to be on the next Jeranism.
I mean, you did at least honestly concede if that were true, and I get that your argument would be that it isn't true or whatever, that it would refute the globe. Yeah, that's fair enough if you haven't seen it or whatever. But it does.
I've seen Bob Nodell talk about it.
Bob did also do it, but we're talking about like very precise measurements done with like Army and military equipment by PhD physicists and stuff like that.
Can we get one of those papers?
Yeah, absolutely.
Can
So
you
anyway,
actually send it though, because you never actually send it.
Where do I send you things?
You're not going to do it anyway.
Where am I supposed to send you things? By the way, everyone that claims I don't send them things,
You don't. You never do.
I don't know. You've never asked me to send you something, or I don't know where to send it to you. But dude, I send more papers than like anyone that comes on this channel. That's the funniest part, is that people say that. It's so funny. But I'll drop it in the Zoom actually right now. I'll drop them on the Zoom.
That's
all right, perfect.
Place for it.
Problem solved. So anyway, so it actually changed with altitude, right? Therefore falsifying that claim. So do you have any other? I get you don't know it, but I'm just telling you it's been done, replicated thousands of times with immense precision. Like
Can you drop it in the chat so we can check it out?
I am, yeah, but millimeter wave precision and stuff like that. So you agree that if that's true, then it falsifies that it's a spinning globe causing it. Are there any other evidences that the Earth is moving, whether rotating or revolving around the sun?
Well, I'd say there's things that happen in the sky that could lead to us believing or inferring that we're moving. There's no optical measurements from Earth's surface showing that we moved around the sun.
Oh, it's a belief
that I know of. It's
So
not
it's
a
a-
belief because we've seen it from space, but you don't believe in that. So
Well, like, but according to your model, even if you were out in space, like even if I grant you space, you wouldn't know if it's the Earth moving around the sun or vice versa, like because of relativity, right? You wouldn't know, even in space.
I think you would be able to measure it from outside of Earth's reference frame. Yes.
No, you wouldn't
Problem
be.
is being on Earth as the reference frame, you wouldn't be able to measure it. But from outside of the reference frame, you'd be able to measure
There
it.
is no absolute reference frame to measure those two bodies moving, so you wouldn't be able to tell the difference between the two moving in relation to each other according to relativity.
Maybe, but you'd be able to see the shape of the Earth for sure, and it's a globe.
Okay,
'cause we've done
okay,
it.
but that's cool. You know, I've already talked about specular reflections and line of sight radio waves and all that stuff, and that's cool, man. But what I want to point out is that this is just a fact. It's pretty interesting that like the Earth could be in the center of the universe, and it matches all observations better because the current model claims, well, yeah, it looks like we're in the center, but it's just an illusion.
How does it match retrograde motion?
It does. There's a kinematic equivalent. So there's many
I knew
ways
that
that
was
work.
coming.
One is that the planets could just change the speed at which they move over time in relation to the background stars because we actually measured them in relation to the background stars. If they just periodically slowed down, then they would appear to be retrograde. They could also just move in relation to the sun. And then from our viewpoint, as the sun moves around us, it would look like they're going backwards, which is the exact kinematic inversion of your model anyway, which is why no astronomer ever would tell you that retrograde proves that we move around the sun because you could just flip it around, right? So there's nothing that
No,
you
I
can
don't
see
think
in the
so.
sky that proves it. I assure you.
If the planets slowed down, they would appear to slow down. They wouldn't appear to loop back on themselves.
Mm-mm.
You see how I can bring these into you? No, they would just slow down in relation to the background star, so they would look like they're going backwards. But anyway, and if they just move in so there's something called the Neo-Tychonic system, which is Tycho Brahe, but it's a newer version, right? And it's just the
Mhm.
planets moving in relation to the sun as the sun moves around the Earth, and it would make it look like they're going backwards. That's the same thing that your model claims, just inverted. So anyway, retrograde doesn't do it. The fact
Did
is,
you drop that in the chat? Maybe
I'm dropping them right now. There's like 12 of them.
no, the ringleader gyroscope one?
Yes. I'm about to
Here's
drop
all
there.
the info,
The
bro.
interferometry measurements changing without that.
Oh yeah.
But anyway, like, so also I'll tell you this too, man. Supposedly the pendulum proves the Earth's rotating, right? It doesn't though. Like for 17 consecutive years, the Elias effect was observed. And it shows that it changes during eclipses and that the amount that the pendulum processes changes with where the sun and the moon are in their phases, like in their periodicity, the periodicity of the sun and the moon, in solar motion and
Yeah.
eclipses.
We went through that. We went through that reference that you gave the other day when you were talking to Bob, and it did not say what you said it said.
See, that's why you never can have any
it changed-
specificity.
It changed. Yeah, it changed insignificantly.
No, it didn't.
Yes, it did. We read.
How
the
much is
pa-
that?
No,
How much is
no,
that?
I
paper,
didn't see
dude.
that yet. It hasn't gotten there yet. No. Oh shit. Well, yeah. Okay, that explains a lot.
Dude, insignificantly doesn't help you. It changes
It
in
does.
direct.
No, it does help me.
Hey,
No, it doesn't. It doesn't though, because it changes
Nothing-
it changes in direct relation to those celestial phenomena. So the
Well,
What
amount
does that
wouldn't
mean?
even,
That means the Earth isn't rotating.
it means that the Earth rotating can't be what's causing it. It means that that phenomena in the sky is actually affecting the pendulum and causing it to process a
Or
certain
something
rate.
else affected it,
So you could just start making stuff up, I guess. Yeah.
like you're doing right now.
No, I'm saying
That
that
something in the sky is affecting the pendulum.
Well, you're agreeing with me. Thank you. Yeah.
No, I'm not.
Yeah, you are.
I said it was insignificant.
You're saying something else
The
did
results
it.
of the study were insignificant.
That's not what the conclusion was.
Was the conclusion?
No, it wasn't. You shouldn't baselessly trust
All right,
Bob
I-
if that's what you're doing.
I'm not baselessly trusting anybody. He actually showed the reference like
Yeah.
that you haven't ever done. And that was another
What?
one where you
What?
said you said another
What's
one where you,
okay? What
you said you were going to send him all these
what's the
things
paper
and
called?
You never did.
Send it to you where?
Not to me, to him. You were going to send a whole bunch of things. You never did.
I don't know where to send them to him. He could message me.
Okay. He told you where to send them.
No, he didn't. Okay, so
Anyway, do you
here
have one
are.
of these in the chat yet? We can
Can we
read?
drop PDFs in here?
I mean, you can. You can always, like I say, share on screen if you guys want to review something together. It's totally fine. You know, you guys are, consenting to your time here, and
It's
I'm
all good.
cool.
But can you drop PDFs in the?
So-
Does anyone know? I'm just curious.
Probably not.
pigging out
Yeah.
and drinking
Anyway.
to cope with the stress.
Send
No
them to you
doubt,
tomorrow.
man.
Yeah, so if it's a file, then yeah, you'll probably want to just do like a drive share or something like that. But yeah, let's carry
Okay.
on. If you guys have any
It's
other
all good.
things you want to
Sure.
dig into before
I-
we get into Q&A.
I'd love for you to disprove all the pseudoscience you said I said in the beginning of this.
Yeah, well, like, okay, so you can't prove rotation or orbit, and you kind of admitted that everything that we see, we can't do anything on the Earth to prove it, and that you just have to believe it. So that's cool. We agree. You just have to believe that the Earth moves around the sun, but
I
you
didn't
can't
say
prove
that.
it.
I didn't say anything about that in the beginning.
You did. You said the word believe. Oh, you mean in the beginning? Yeah. So I'm saying we're concluding that part, and we're moving on.
Oh,
Yeah. So you have a belief that you can't verify, and it's
I
kind
have
of
a
like
belief we can verify the rotation of Earth.
kind of like a religion, you know.
I have measurements that we can, and I'm guaranteeing those references you have don't say what you're saying they say.
When you
Just-
say
just my
guaranteeing, like
opinion.
you would like to bet on it, and then
All
we can
right,
have a
guys,
stream.
we're
and-
starting to do the
Yes.
meta. We're starting to do the meta
Yeah,
debate here.
the
So
meta.
let's try
It's
to
never worked out. It's never worked out. So I'm using history as
before everybody
future.
starts making bets on modern day debate. Is this a place to
Sure.
make bets?
Oh,
I
it's
mean,
an easy way to call out BS, though.
Is
Dude, they could incorporate some kind of a thing with that, you know? Bet on these guys. Hey, that's an idea, Anson. That's what we ought to do, brother. We ought to set up a betting parlor for these modern day debates, man. You know, we could comment, but set up a thing. All bets have to be in before the start of the debate, right? I don't know. They probably find a way to raid us and kill us for that or something. Because that's a good idea, though. So if you ever see it out there, just remember you heard it here first.
that why we don't have one link that you asked that you said you put in here yet?
And they're all PDFs.
They're on your
You want me to start
machine.
pulling them up? You want me to start pulling them up?
if you want to
Yeah.
bring them up, like say on your device,
That's what
we
we'll
can
do
look at
actually,
them.
because I'm making up that I have them. We'll just start pulling them up
I'm not saying you're making up, you have them. I'm saying they don't say what you say they
and
say.
drop PDFs in the Zoom. All right, let's see what all we got here.
Let's share on over. There you go, and you're up and running, and we'll give
Sure.
you the floor.
Okay, save as. Wait up.
So they're measuring ether drift with optical wave band.
Yeah, that's what
Okay,
that's
cool.
that's what it
So,
is. Yeah,
Cool.
that's what it
Scroll
is. Wait up,
down
wait up.
and-
We're gonna keep. I'm trying to look for a specific paper. It's
Is this not one of them?
that one's fine, but here you go. Here's the good one. Save as, download. So they'll start popping up right here. I have. a
So
ton
this
of
is
them.
electromagnetic wave propagation.
That's
So
what
we're-
light is. Yeah.
We're not.
light.
So we're not talking about interferometry.
Yeah. That's what light is.
I know they use light in interferometry, but that was
This motherfucker doesn't know that lights and electric. Wow, man. Why do you even try? Why do you even try? Just shut the fuck up if you don't know.
Yeah,
Man.
it's because their whole system is based on relying on secondhand knowledge, which is
Yeah.
handed down. And so, it's so easy when you don't, when your education that you're rewarded for is like, relies on that system and not thinking for yourself. It's, that's it, isn't it? You can't,
Yeah.
you've got to sort of change your sort of, your idea of what learning is.
Well, yeah, that's what I've said too. Is they're unable to put things together and shit, and until someone has, of an authoritative nature, mind you,
Yeah.
tells him that that's what light is. He doesn't know that. He can't put that together. He's never heard that before because it's just not in the paradigm. It's like just regurgitation of shit that you've been told without actually thinking about it.
And like you say as well, like the specialization of subjects is like, they can know a lot about certain experiments or certain areas, but then, like you say, it's not putting the pieces of the puzzle together, which is what you need to, to see what's going on.
Right. And if you don't, if you look at it from the overall perspective, you find out, well, this claim over here kind of fucking debunks this one. What's going on here? You see these contradictions all over the place, man. One that comes to mind is the idea of how sun rays behave. They're parallel when you're measuring sticks and shadows, but they're crepuscular when we have an eclipse. I mean, what the fuck? See, doesn't work.
not testing anything using interferometry.
Yes,
Am I
it was.
incorrect?
Yes, it was.
Okay, so go back to it. Let's read it.
Okay. What do you think this means here?
It doesn't mean interferometry. I want to see where it's
What does
talking about
optical mean? What does optical mean?
light.
Okay. So
Light. There's other
Visual.
things of light other than interferometry.
yeah, but this is based on Mount Wilson Observatory, which is Dayton Miller's replications of Michelson-Morley, which is interferometry.
You can't equate the two if that's not what they're about.
What? Do you not
All right.
see right here? It says
I'm-
Mount Wilson
I'm just
Observatory.
asking.
That's
I
Dayton
wanna-
Miller. So,
Okay.
I mean, I'm sorry that you don't understand this, but you know,
I'm just looking at it. For
just
the
see how
first
many times
time,
it says
so let's-
interference pattern, interference bands, interference bands, interval, interferometer. Oh my
Okay.
gosh. Like, obviously, I know what I'm talking about. You've never read it. So why are you acting like you're going to
because you just searched the thing for inter. What are we talking
interferometer
about here? Let's-
specifically? It's talking about an interferometer specifically.
Okay.
So can we you just admit you were wrong here?
No, we haven't read it. Showing something is not proof of anything. Where does it talk about the interferometer? What does it do?
Okay, let's look.
What did they test? What was the conclusion?
Oh, this
Interferometer based on the work of
just
such
wanted to go
interferometer based
down-
on the light passing.
He's wanting to go down and get fucking because he doesn't have any kind of a refutation. He's just going, well, show me this and show me that. And where's the
Time
spark plug?
wasting.
Yeah, where's the spark plug? If it's such a good car, where's the spark plug at? Oh, show me the spark plug. Oh, yeah. Well, where's the fuel pump? Let's see the fuel pump. Does it have a fuel pump? Can you prove a fuel pump? You know, it's like, motherfucker, it's a car, you know? Holy shit.
In a forward direction, returning to the observing point along the same path, the Michelson's interferometer sensitivity was low to the original ether drift effects. The measured value D in such a device visually observed bands offset interference pattern expressed in terms of visible bandwidth. The entire paper is about replicating Michelson-Morley with interference patterns. Here's another one: modified Sagnac experiment for measuring travel time difference
Why
between
would you
counter.
on the different thing? All right, whatever.
Dude, these are huge papers, and I'm showing you that it's been done dozens of times. And I'm going to keep pulling them up.
Travel time difference between counter-propagating light beams in a uniformly moving fiber. You're
Yeah.
telling me this is about measuring interference patterns at varying altitudes about Earth's rotation.
These. I'm going to find the specific one that goes up. in
Yeah,
different
please
altitudes.
do, because these aren't it.
These are all showing that the propagation rate changes relative to many conditions, including altitude. My guy.
Many conditions, including.
Yes, that's right.
Where does it say that?
I'm about to find the one that specifically.
Okay, thank you. That's all I'm asking for is the one that actually says what you're saying it says.
All of these show a relationship with solar motion, my guy.
Oh, now it's solar motion.
That's what like I said that it changes with altitude and stuff like solar motion. I said that the whole time. But neither one of those work in your model, bro.
You said you had a whole bunch of references that show that it changes with altitude. I'm looking for that one.
Okay, I'm trying to find it. Here it is.
Okay, thank you.
All right, now let's come over here, download. Okay, you want to redo the whole paper?
Because quite frankly, when you don't have it, it's going to be interesting.
What? That's what this paper is about.
Well, you said that about the other one, and they weren't. So what is the
No,
title? of this
no,
one?
I told you they were about interference changing based on very.
He is getting actually belligerent. If he is showing signs of what drinking will do, he's just being totally belligerent.
The
No,
change
you
in the
said
speed of light relative to altitude and solar motion.
Now
That's what I was saying.
you're adding solar motion in now. You didn't say that.
No,
at the
I said it.
beginning,
I
but-
said it earlier.
No, you didn't.
Objectively.
You
Jesus,
said that about the
Christ.
pendulum. Scroll. What's the title of this one?
Ethereal wind and experience of millimetric radio waves propagation.
Ethereal wind in experience.
The
of-
phase method of anisotropic media. Do you know what that means?
Wait, hold on. Experiment reaches researchers from the ground channel phase characteristic with 8mm range radio waves propagation have revealed the problems connected with its model elaboration. Okay, so what does this have to do with what we were talking about?
Okay. So do you know what anisotropic means?
Don't start with the words. Okay, Austin, please show me how this proves what you said it proved.
Hey, it's
I'm
somewhere
not
to
spending 2 hours.
Don't use 3 something's big words. Don't use those 50-cent words with me. I don't know what they mean. They make me feel stupid.
I was talking
He's asking if you know what it means. Let's hear what it means. I'd like to know.
about words with you.
Yeah, but it's somewhere towards the end. And do you think what's so funny is you're said, here we go. The expression allows to calculate high altitude relation of the ethereal wind horizontal component for the latitude by the work results obtained at altitude blank. So this is specifically about the changes in altitude right
A
here.
radio
huh?
link. It's talked about a radio link there, though. Why'd you skip over that part? What are
What?
you using to measure?
An interferometer. Actually, specifically, they're using radio waves, which is it's a certain spectrum of light. You know that there's radio interferometry, or you didn't know that either? This is embarrassing for you. Did you know that
No,
radio
it
is
certainly
relate?
is embarrassing. Hmm.
So now that you said it wasn't about altitude, and specifically I showed you that it is changing with
You're
altitude.
cherry picking words, Austin. Where's the conclusion? Let's go down
Dude,
to
this
the
is what's
conclusion.
okay.
This is what's frustrating.
No, what's frustrating is you're trying so hard to get like a gotcha. You couldn't even bring up one paper and know where anything is ever. So I immediately went and looked through tons of
What?
PDFs, pull up a paper, and then I'm supposed to have the whole
All-
entire paper.
All we're showing is that you can't.
You have to
support your
right when I'm
claim.
about to get to the conclusion that exposes you, interrupt me every time very tactically.
Oh yeah, that's what I'm doing.
That is what you're doing.
It is. There he goes, right into a child. They all start acting like a little bitch. They all start acting like a woman. And I'm not trying to insult women, but these guys will start acting like a woman does in an argument. Oh yeah, that's what I'm doing. Sure. Well, if you think that, then that, and it's like, oh my God, man.
Yeah, man. What I get is like that he's constantly trying to slow Wits it down and cut off the flow, like almost to kind of. It's not going to work though to make him forget like the point he was trying to make, because he knows that when that point's made, it's going to be like, you know, it's going to make sense.
Yeah.
So he keeps injecting the little like pointless words to kind of break up the debate.
Yeah, he was just getting ready to go, well, that's radio, not light. And Witsit cut him off, and radio waves are light, bro. It's a bandwidth of light, okay? And you didn't know that? No, he didn't know that. That's in. Yeah, I think you're right. Yeah, he keeps trying to go. Okay, well, we'll just go to the conclusion, because he's looking like Witsit said. He's looking for that gotcha, and that gotcha is just not there.
So anyway, the point is that obviously I don't have every single paper memorized off the top of my brain. Like, on page 37.8, it says, like, are you kidding me?
But this is what you do. You have references, you claim the thing. There's no time to actually read them and understand them here. So then you claim you're going to send them and you never do. And then everybody goes on their
I've
merry
sent
way.
them to everyone that's ever been on this show with me and asked for them. Every single person. So that's just a lie.
It's not true.
Okay, name one person that was on this show that asked for the sources. I didn't
This
send them.
show? Okay, I don't know about
Okay,
this show,
cool.
but I've
All
seen
right,
you
cool.
do
So
it
we're
at
gonna
least
move-
3 times,
right.
including to myself.
No. So this is what I'm saying. You're just trying to character assassinate because you can't handle it. Just say out loud again that if the interferometry measurements actually change with altitude, then it debunks the claim that it's because the
Show me
Earth is
where
a globe that's spinning.
Show me where that happens. Can we see what this happens in this paper here?
Yeah. So I'm about to find the chart right here. Let's see what
Sure.
page is it. Trying to find the exact word. Let's see here.
Oh, right.
Er-
Yeah, they're having the big scroll there.
I know that's what I'm saying. I'm trying to find the chart. I don't know where it's
Feel the
at.
need to
It doesn't
fold
matter.
that
It's just a fact. Here's what I'm saying though. This paper is obviously a big paper. I'm not telling anyone to believe me.
Okay, that's fine.
I'm saying it's a fact. It's a fact, bro. Look,
Yeah, we can move on. We can move. That's fine. We don't need to watch you scroll through stuff. I'll read it.
It literally, I went straight to where it talks about it changing with altitude. And then
Mhm.
here it is talking about how it changes based on solar motion. So they actually tested it during different times of the year, right? Differences available can be explained by those with the calculations executed in the supposition from, I got to find exactly where it is. I don't know off the top of my head. But here again, this is based on Michelson-Morley setup, right? That's what Mount Wilson's all about with Dayton-Miller replications. So this test is objectively about redoing Dayton-Miller's replication of Michelson-Morley with interferometry, showing that the actual motion detected with the interferometry changes with altitude and throughout the year based on solar motion. And this cannot be explained if the assumed motion is the Earth being a globe spinning. That's just a fact.
Okay.
So
that's your interpretation of what this
that's
says.
the author.
And,
That's their interpretation too.
okay.
Well, I'm glad we're on the
We
same.
can move on. I'll read this and I guess do a separate response video on what I
All
found.
right.
there. Don't mind me.
Thank you. That's so frustrating for me.
Get your pretty faces
Anyway,
back on the screen there.
but the main point is, like, just so you know, interferometry has been done that changes with altitude and then throughout the time of year, and then pendulums also change during eclipses and solar motion and based on the periodicity of the sun and the moon, which would falsify that it's the Earth spinning. And no one's ever shown a pendulum not precessing at the equator. So we got no evidence. In fact, that refutes the claim the Earth is rotating. directly, and
If it was true, maybe, but I
now we're
disagree
stuck with the
your claiming,
stationary
so-
Earth.
Sure.
And so you believe in a stationary globe.
Sure, I believe
we-
in a stationary globe, I guess. Yeah, that's right.
Sure. And
I
we
showed you-
falsified the globe this
I showed you the
stream, so-
motions. You claimed you falsified it by showing papers that didn't falsify it. So
This might be a good time for us to move.
This guy's just tiresome. Well, you didn't find the specific fucking words that I wanted you to say in that 900-page fucking document. So therefore I win. This guy sucks, man. I'd like to go up against him.
Did he just say he believes in the stationary globe, or was he trying to be sarcastic?
Yeah, I think he was being sarcastic, but he actually must, I mean, according to what we've seen so far, because oh, you didn't show any proof of that. Well, oh no, here's like 900 different PDFs of people doing the same fucking experiments, different altitudes, everything. Let's go. Oh, well, let's go over every part of each and every one of those. Look, dude, you're just ill prepared for this fucking conversation, bro. Stick to what you know, which seems to be the 2018 globe arguments.
Yeah, and it's this thing too of keeping the information like hidden and away from like public debates like this. He wants the papers sent to him so he can look at them, and he wants official peer-reviewed proof of every point that Whitsitt makes. Like, it's always taking away from our freedom to see these things ourselves, and share the information. So that's why these debates are so good, man.
Yeah.
It's like the public can no longer have to think of science like I did, man. It's like this thing that will never be accessible. It is like, it doesn't make sense when it's flat earth science.
Right. And it's like, look, it's just science, and that's like I had that Martin guy come on and he says, well, what's your flat earth physics? I was like, what the fuck do you mean flat earth physics? What in the world are you talking about? Physics is physics. There's no such thing as a flat earth physics or globe physics. It's physical laws, what motion, things that are, things happening. It has nothing to do with that. And so, they get, well, we have a predicted rate of fall. Well, okay, so what? I'm not disagreeing with your predicted rate of fall or whatever you want to go with. That's fine. Your cause, that's what I'm barking at. Okay, I'm looking at your cause. How did you get this imaginary cause derived from a Greek word meaning weight or heavy? Don't know. Pretty weird. So things fall due to weight. Yes. What is weight? Weight is a relative density of an object within a given medium.
And it's like they've ignored every other reason for the processes happening, and then just bundled them all together under gravity. And that's, again, it's to stop people looking at the real physical world and thinking that it's all happening because we're just getting sucked towards the earth. Whereas we know it's all different reasons.
Right. Well, Elaine, listen, hon, the thing is that you're not going to wake that glober up, but those people out there that are paying attention to this and watching it that don't really know, they're the ones that are benefiting from it. That's what Anson was just saying. I saw several people in the chat say they've learned quite a bit just from watching this little debate here too. And that's what we need. Whether you believe the cosmology or not, don't hold on to it like a religious belief. If it upsets you, and this is to all people, if you think the Earth's a globe, if the prospect of it not being a globe upsets you, ask yourself why, and be honest. That's a question you need to ask yourself. Why would I be so upset about this topic? It is really quite irrational, and it's quite disturbing when you uncover why you get so upset.
move
That's
into
fine.
the Q&A there, guys. And a big thank you to Globy McGlobeface for coming out and doing the debate. We were going to have you hosted, but then, some things slipped through our fingers, and we're so happy that we got you here. And of course, Austin, thank you for being here. It's always a lot of fun when you're hanging out, and yeah, always a great time, honestly. So we'll give that big round of virtual applause as we get into our Q&A, everybody. And as we're getting into it, I usually like to let our speakers have a chance to grab themselves refreshments. If you gotta run to the washroom, do whatever you gotta do, now would be your time. Speak now or forever hold your pee.
Definitely go refresh my drink. I'll be
All
right
right.
back.
No problem. Take your time.
Oh, you're saying step away? I'm gonna step away real quick too. Then
He got a great big old bottle of Aristocrat. Yeah, he's gonna go after. So these guys are going to get a drink or something. Let's see what happens.
All right.
Be right
Yeah. Like I said, yeah. Speak now or forever hold your pee. We'll see you in a second, guys.
yeah.
All right, for all you guys hanging out in the live chat, we are going to move into our Q&A right now in just a few seconds. Our question for Witsit coming in from Kango44. Thanks for being here again, Kango. The debate has not started yet, but I'd like to know why you're such a crybaby. Kango, you came in here before the debate. You know what? If there were any crybabies, I'm not going to call them out, but I'm just going to move on and behave myself. We don't have to entertain that, guys. Let's see if we can get some substance. LJ asks, if it's a globe, why doesn't half the Earth stay lit?
What?
This is from LJ. He is our honorary, always asks flat Earth questions, even if we're not having a flat Earth debate. LJ asks, if it's a globe, why doesn't half the Earth stay lit?
It does stay lit. So not sure what the question means. Half the globe is always lit. When is not half of the Earth lit? I'm confused by the question. So I guess the answer is it always is lit. So your question is moot.
Did you have any thoughts over there, Austin, to kind of build on what LJ was saying so we don't just move on?
I mean, other than like sometimes way more than half of it is lit, and then they just start making up excuses as to why. But I don't know. I don't know if there's specific times where not the full 50% is lit. I know there are times where way more than 50% of the sphere is lit, which wouldn't make any sense geometrically. But they just make up excuses, and they claim the light bends around the Earth, all around the Earth, and it's just there's no way to falsify it. But
Is
that's
that
all
what
I
he's
can
talking
think.
about? Is he talking about like the July 8th observation, the day of July 8th thing? Is that what he's
I
talking
don't know.
about?
I don't know. I think it's roughly 65 to 70% of the Earth is
Oh,
lit up at
definitely
one
not.
time. Not talking about the population, talking about the
Definitely
actual
not.
physical Earth.
All right. Let's move on to the next question there, fellas.
Knew what you were gonna say.
75% of the Earth is lit up at at a time.
I said 65 to 70% of the Earth. Yeah.
Send me that source.
Okay. The globe claims that it's because it actually wraps around the ball a little bit. Official
It does wrap
claim.
a little bit. Yeah. The light,
Yeah. So
the light
I'll
does
teach you. I taught you your
diffract
model.
around. Yeah.
Good.
75%. You taught me 75% of my model.
No, I said 65 to 70.
Let's carry on because LJ had another follow-up
It's all the
question there. Oh,
grumbling
he's brought on.
going
Oh
on,
no, not the glasses. What's it?
These are my Glober glasses. If I'm just saying, if I need to give the Glober answer, I got you, bro.
You causing trouble?
Oh man, I'm cracking up already because every time
I got Moonshadow over here causing trouble. What are you causing trouble for, you little mutt? Huh? Huh? You get old Brandy growling at you? You must have pissed her off. All right. Crazy thing.
My
see those
mullet hat I
glasses.
can put on for flat Earth. We can switch roles if you want.
Got to be a little nasally though.
So we already asked Globy what he's drinking. I'm having this is a beer, is what it's called. From This Is 12 Beer. It's a very cheeky thing that you would only find probably in Nova
Brand
Scotia.
Van
So
Tifa.
Austin, it's only fair that we ask, what is it you're having for refreshments tonight?
This is just water with some electrolyte mix in it, and I had a coffee.
Coffee and water, and I'm over here with the beer. And Globy's having a little bit of vodka, so that means everybody's just hanging out, having a good time. So let's carry on with the questions, and I think there's been a lot of fun. So LJ, what's the proof of Jupiter's mass, size, and gravity? So it's
Talking to
proof of
me?
Jupiter's mass, size, and gravity. Let's ask him to you, Globy.
What's the proof of its mass?
Gravity! Refraction.
Well, you can measure its angular size, and then using spectroscopy, you can figure out what it's composed of, and then make an assumption based on its composition and size, what its mass would be. So yeah, it's based on.
White Claw is not a beer, Ryan. We've been over this, right? Right.
It would be based on a measurement of its composition.
Yeah, I was gonna say. I was thinking the
All right.
same thing.
I know flat earthers don't like spectroscopy. They think it's magic, or fake, or something. But
We were going to move on, but I think, yeah, if you want to respond, Austin, it's up to you.
Not really, man. Just like shit, look at a barrel 100 yards away and tell me what elements are in it, and holla at your boy.
Alrighty. All right,
Sure.
let's carry on then. See, we got some more. Kango44 asks, and also if you're hanging out in the live chat and you've got a question, get it into the super chat, because these guys, like I said, they said earlier on that they don't mind going a little long. So if you guys have questions, we're willing to take them and see if we can expound on what our speakers think. Kango44 says New Zealand is in daylight 3 hours before Sydney, Australia. Sydney is only 650 kilometers further away than the total side of New Zealand, which is 1,600 kilometers. Question for both debaters: why does the light take an extra 3 hours to travel 650 kilometers?
Because New Zealand is a bad neighborhood, and it doesn't like to go through there, so it's very hesitant.
Well, it's a little much, but yeah. You guys got anything on that?
It would be relative to the position of the sun throughout the year. It doesn't like. Well, I don't even understand the exact question.
well,
How much?
so
How
the-
long it's actually lit is not going to be the same at all times. That's obviously a fact, right? So
The issue is that I think what he said New Zealand, right?
Yeah, New Zealand is in daylight 3 hours before Sydney, Australia. Sydney is only 650 kilometers further
Yeah.
away.
What he's saying is that's
Got
impossible on
carjacked.
flat Earth because the sun's right there. It's only 600 kilometers away, so it shouldn't be blocked by anything, right?
oh, what?
That's what he's getting at. That's what I think he's getting at anyway.
I don't know, man.
And
There's
the-
light attenuation, man. Every position of the sun, including what was in your opener about which angles they set, can be explained with the celestial personal sphere.
I'd love to.
Sexual
I'd love to
personal
explore
spirit.
that concept. How
I
does
have
that work?
I have a sexual.
You can only
personal
see so
spirit,
far.
and so my sexual personal sphere is about, but I keep that to myself. I don't go on air and talk about it.
Each distance equidistant. There's
Mhm.
actually a logarithmic relationship to the elevation drop. So you guys say 60 nautical miles per degree. And
Mhm.
that's linear because the surface of the earth is curving. Actually, you have to cherry pick between like 15 and 70 degrees to do that. And the logarithmic would happen outside of that range. And so actually just a logarithmic relationship of curved visual limit would be exactly the same on a plane earth. You guys flip the way that we see with the visual limit, claim we could see forever. And that perspective doesn't affect the stars. And that we look back in time.
I didn't ask you how. I didn't ask you how the sphere works.
Said you wanted to
I-
explore that concept.
Yeah, no, I understand how your sphere of vision is constructed. However, when you're south of the equator, the sun sets to the left, always.
Mhm.
Has nothing to do with where the sun is in your azimuthal grid of vision. Could be
Yes, it
north of
does.
you, could be south of you. It's setting in the same direction.
Globey's starting to slur his speech just a little bit.
It's like it would in the azimuthal grid in the model.
It would not. No, in your model, if it's north of you, it would set to the left. If it's south
No.
of you, it would set to the right
It's
Because it's-
optically
because it would be doing this, right?
no, but it's based on the actual curvature of the visual limits
But just
based
in-
on you
like,
in the
yes or
center of
no?
it.
This is what
been
your model
modeled-
says.
It's been modeled out, and based on
Mm-hmm.
your actual curved visual limit, right? There's a curvature to your visual limit, so the
Mhm.
apparent light source is going to move in relation to that, and you being in the center.
So
So-
why does it not matter if the sun is north or south of you?
Because it's all relative to your personal visual limit and you in the center of it.
Right. So if it's north of you, it should be setting which way?
If it's north of me, it sets a little bit to the right, and if it's south of me, then it
The
sets a
other
little
way
bit to the left.
It's the other way around. But yes, it doesn't matter because it's always going left south of the equator.
There is no other way around.
Yeah, if
you
it's
could just
north
do it
of
both
you,
ways.
goes
Always
to
west.
the left. not
It's always
the other way,
going
but
west, east to
You're
Well, it
west.
saying
depends on
it-
which way you're
west.
looking.
Yeah. See,
No.
this is-
Everything is going east to west. You turn around and shit. If you look at it one way, it's going to be going from your right to your left. If you look the other way, it's going to go from your left to your right. It never doesn't change directions. Okay.
you're obfuscating. So
No,
the
you
point
just
is,
said
it doesn't
something
matter.
wrong.
No, you did, but it doesn't matter.
You want me to
It
pull up
doesn't
an
matter.
observation of it? You want me to show
If-
you how it works?
Yeah, go ahead.
All right, I got you.
And then I'll show you actual video of reality.
Oh, so you're just gonna hand wave dismiss it and say it doesn't work anyway?
Or you can show me some computer model of what you think happens, right?
Well, let's show
Oh,
our
I'm-
audience. If you guys want to show what you got,
Yeah.
let's see.
Yeah, I'm gonna-
'Cause
I'm gonna-
I do think this is one of the most simplest proof of a globe. It's
Oh, I'm
quite-
sure
it's
you
quite
do think
nice.
that. Sure you do think that. All right, so share screen.
You got it.
Now watch, you see the sun moving over to your right as it sets based on where you are. And you don't have to
Well-
change the time of year. Let's go ahead and clarify. You don't have to change the time of year. You can just change latitude. It's going to be
Mhm.
relative to your position and latitude in relation to the sun. You'll see that the sun sets a little bit to the right of where it is. And then you'll see, oh, it does the opposite on the other side. Now, if you just change latitude instead of changing time of the year, it would be the same thing. So inside your personal visual limit, that's why you see what you see.
Yeah, so that's
Oh.
what I said, right? Depending on if the sun is north of you or south of you, it would set different directions, right?
Yeah, on our model. Yeah. So,
On your model,
Yeah.
because of the grid of vision, right?
Yeah.
That's a requirement of your model, right?
well, that's how we actually measured the sky in the first place. And your model
Yeah.
did the same measurements, but claimed that we can see infinitely in straight lines forever, and perspective doesn't affect stars.
So do you disagree with the stellarium data?
No, that's actually built on the stellarium data.
It is.
Yeah.
Oh, but
You don't know
can
the difference? Let me
Can you
explain it.
show me that in the southern hemisphere?
Yeah, sure. But you're diverting because your whole home
Uh,
run argument just got dunked
I'm
on.
not
But
diverting.
real fast,
anything.
man, I want to point something out, man. Okay. I want to make sure the audience understands. So I'm going to say it pretty quickly. But so we see in reality that say the street lights look like they're going down because of perspective, right? Or a
Sure.
plane coming toward you looks like it's going up, then going down as it goes away from you, right? I mean, that's what perspective does. It makes things look like they converge. Flat
Mhm.
Earth says the same thing happens with the stars. As you get away from Polaris, it'll drop. As you get closer, it'll rise, right? So we're saying that perspective works on the stars. The globe model says, yes, perspective does do that with everything else, but not when it comes to the stars. The stars just so happen to do the same exact thing, but for a totally different reason, I promise. It's because the Earth is curving. And the reason perspective doesn't displace the stars is because they're so far away. And then they assume that they're infinite distances away and they're equal distances away, and that it has to be the curved surface. So that's where they get the 60 nautical miles per degree, right? And whenever you don't assume that crazy nonsense, you understand that we have a visual limit of perspective, and you're going to actually get a logarithmic relationship. You have the same 60 nautical miles per degree. You can map the same thing out. It's going to be logarithmic below 15 degrees and above 70 degrees. And they just reverse engineered that visual limit to make a sphere. That's where you get the radius value. And then they did the
Sure.
visual limit.
You're-
What a
you're way
coincidence
off
that the
top-
ang-
you're way off topic.
All right, whatever, man. I'm sorry.
You're-
For those who actually want to know the truth, they took the way
No,
our
you're
eyes
just saying
see and they
words,
made a
man.
globe model.
You're just saying words. You're way off topic.
Just saying
Okay.
words.
Yeah. So
Okay.
let's
Stop saying words I don't know. No.
It's sort of catch 22. It's like, if I can't use words, how else can I communicate with you? Let's just do some sign language or something, you know.
I know, right? It's like, God damn, I don't understand what you said, so you're just saying words and stuff. Stop saying stuff. That's what me and my wife do when we're picking on each other. Oh, shut up. Stop saying things. Quit using words.
let me explain, because I don't think you even understand what I'm even trying to get at.
Oh my gosh. I just showed it.
Yeah, and it's wrong.
It's not wrong. It's showing the exact observations we see in reality.
Come on, man. Drink
All right.
a little bit more. Make
Yeah,
an
while you
ass
bring
out of
that
yourself,
up,
bro.
Not sure what you're bringing up. We'll remind everybody that we
He's
did close a
diverting.
poll, and I'm going to open up another one in just a second here, so keep an eye out for that in the live chat. Your computer's giving it a good think there. I thought that was the time for me to back away. Maybe I should have vamped a little bit longer. Oh,
Well, I mean, people that actually listen to me know I just answered it and showed it anyway, right?
Zoom does not like when I'm sharing my screen.
Oh, there we're
The
talking.
ether. It's the
Is it
ether.
back?
It's loading rather slowly.
Out of curiosity, what else should I say other than words?
It's not letting you screen share for some odd reason.
Like when you say you're
Richard
just
got
saying
me there.
words, like what else should I say? Numbers?
I heard somebody said that. Who said that? It's talking numbers.
I don't know if Globy is here. Are you still there, Globy?
There you go. Christopher Allen said that when he said numbers.
That's
Speaking
not a
numbers.
good sign, Woodsett.
It's the ether, baby. The ether ain't playing.
Oh no, we might have to get Globy to back
The
out.
screen share may have messed up his Zoom. You may have to come back.
Maybe he tried to do it and it screwed up. So
He's trying to screen share Stellarium, which is a pretty big program, right?
okay, I'm not sure what the program is, but
It's like all the data of everything in the sky, and he has it actually downloaded instead of the browser. So he's trying to pull up like it's like just as big of a program as Google Earth.
oh, and yeah, he
It
likely
crashed.
has dropped off because I
It
think he figured
crashed.
out that he is not he's not able to be heard right now. So Globy, definitely rejoin our chat. If we don't hear from you in 5 minutes, then I'll send him an email, and maybe we can move
He
on
passed
to
out,
some
bro.
other things. I do have a little bit more housekeeping to do, so let's take care of that right quick. Once again, thanks
ran.
for being here, brother. I appreciate you.
He's looking so bad.
Mean Joe,
Oh, here he is. Wait.
for $1 said nothing. So for that $1, I will just say, let's go over our first poll right quick. And I will just remind you guys, there's 1,200 people watching in the live chat
Tapped
right
out.
now.
Right on.
And we're under 1,000 likes. How is
He was trying to run that fucking shit off of his computer instead of doing it off the browser, and that's ridiculous. If you're running something like, you know, like I'm running StreamYard and shit, I'd have a rough time trying to run that. You know, that big of a program. If you don't have the memory and shit like that, it crash your system. And I bet you that's what happened. Or he might have tapped out.
that? What are you guys doing? Like I put in the
Much to
live
like.
chat. They got arthritic thumbs or something. What's going on? No, I'm bad. I'm bad. Yeah. Let me carry on
He's
here.
big.
So
Dude, I got my glasses
Yeah,
too.
we're
I can
good.
answer the glow questions if I need to.
you behave yourself over there. I know how much of a character you get to be if you get those glasses on your face. Instantly, I saw them. I was
Yeah,
like,
don't drink and
"Oh,
debate.
no."
You're right. Save lives.
He's going for it.
100.
All right. So the poll we had earlier was the Earth is, and for flat, 51% voted flat.
Whoa, 50.
Let's go.
38
Let's go.
38% voted a globe. And as per the first thing I ever got James to say on YouTube, and I was like, that guy's cool. I'm going to email him and see about like working with him because that's funny.
Sorry about that. I'm back now. Anson, I lost Anson. Anson, click that link and come back. It's cool, dude. For some reason, I lost internet connection, and I don't know, man. That was pretty weird. Anyway, bring this back up where I was at. Holy shit. Well, that kind of sucked. I looked down here and my internet had gone, and then it came back for some stupid reason. We can get a transcript of MDD chat. Lost Anson too. Yeah, I don't know what happened, man. Anyway, we're back.
A loaf of bread. So yeah, 1,200, almost 1,300 people watching. Smack that like button. Globey is returning to the chat now.
Wowza.
Yeah, I think that program may have eaten up a little bit of too much RAM, or maybe a little bit too much.
It made my entire computer restart.
No, but that was fast. If you reset, that's a
I
good
did.
start.
I did.
Did you know? You know, I
did.
actually reset earlier too.
I had to reinstall Windows this morning though, so I don't know. I might be having problems, but
Well, let's carry
let
on.
me try one more time. If not, maybe I can do it on my phone. I don't know.
Oh, okay. Yeah, if you want to try it again here, that's cool.
All right.
I already explained this, man. You know I know. You know I have an answer, right? Like you know that.
I know you have what you think is an answer, but you don't.
He did
Okay,
reboot.
good.
There's Steam.
Just
and
explain
everything.
the specific linear and logarithmic relationship with a plane as opposed to a globe.
Yeah, that's cool and all, but
I don't think you get it. Well, while you're loading your program, what I'm saying is that if you take the actual way that we see and you reverse engineer the angular resolution limit, you get 3,958.8 miles if you actually assume the loss of information is curvature of Earth. So you can hijack the way we see and get a radius of
Yeah, I'll laugh my ass off.
3,958.8 exactly, right? Which is what the globe claims to be, and claims the reason things disappear is not because of resolution limit, but because of the curve. Same thing with
It's not even this
3,950.
topic, Austin. We already talked about that. It's not even this topic.
Same thing with Polaris angles, right? So that's how you got the latitudes.
No, it's not. So we're in July now. So where's the sun? And we're in Australia. And it's July.
Okay, so
the sun's in the northern
It's out
sky.
further. It's out further to the south.
No, it's in the northern sky, opposite.
Oh, you're saying right now or in July? In July, it's in the north. You said in July in Australia. I don't know, like what you were
Australia
saying.
in July. In Australia in July, the sun is
then
north of Australia.
Why would you
right?
bring up Australia? Yeah, okay.
Because I'm going to the southern hemisphere. That's
Either
why.
way.
Can you guys see my screen, by the way?
Yeah, everybody can see your screen.
Okay, good. So if we watch the sunset,
Oh,
it sets to the left.
I just showed a video of it.
Yeah, you said when the sun is north of you, it sets to the right.
Are you supposed to be showing something beyond a loading screen right now?
Shit. Yeah, I'm playing an animation. I'm saying it's not working.
No, to the right or to the left is not an accurate denotation.
It's to the
of
south.
situation.
It's not on the screen right now. Maybe you need to share a different screen.
Depends on
All
which
right.
direction you're looking, man.
Let me.
You agree if you're looking west and east and left and right are different?
Yeah, I mean, you're always looking west at a
Right.
sunset, aren't you? Could be northwest or southwest, but you're looking in the western sky.
Okay.
So I'm assuming that you understand we're looking west when we're talking about this.
Sure, yeah.
Okay.
But it's same situation happens with the sunrise, right?
All right, let me try to share.
You don't know.
Yeah, it does happen with the sunrise.
Yeah, and it's explainable with what I just explained to you. If you understood it, then you would know that we just reverse engineered that to get the globe anyway.
It doesn't
But
matter what you
have to
think.
work.
We
It would
reverse
have to work
engineered.
on both. It would have to work on both.
All right, I just shared Stellarium specifically, so let me know if you can see this now.
We can see it.
Okay, there we go. That's
All
perfect.
right, so we're in Australia, and it's July, so that's so the sun is north. Now watch where the sun sets. Okay, we're looking west. Shit, sorry, hold on.
Oh, I already showed this.
Go back to July. I hit too many buttons. Okay, so just look where the sun's setting, right? Setting from the north to the south.
Yeah, man.
Okay.
I just
Yeah.
showed that.
No, you didn't, but hold on.
I literally did.
I'm gonna go to December. I'm gonna go to the end of December. Okay, as far south as we can go. So now the sun is in the southwest sky, and it's still gonna set to the left. Okay.
Okay.
And this gets more pronounced if I go a little bit more north, but I'm in the southern hemisphere. So according to your explanation a minute ago, depending on whether the perspective is of the sun, depending if it's north or south of you, it should set in different directions. But it never
If you see
does.
if you see the actual position and then you didn't actually represent what I said my argument was.
So how can I put stellarium to represent what you said?
Stellarium is showing you what we said, because if you, well, actually, I'll show you the actual measurements of stellarium. That's how we actually made the model, right? You understand that, right?
I don't want you to show me how we made the model. Okay.
Okay, well,
The
this is
sun
how
on flat Earth goes like this.
Yeah, man.
It doesn't matter if the sun is north or south of you. In the southern hemisphere, it
All right.
sets to the left.
I'll share
Make-
my screen, and this one's
Yes.
narrated for you, so I think
Good.
you'll
Make
get
that
it.
work with your azimuthal grid.
I think you'll get it, and then we can move on, because this has been the longest question ever. So I'm going to share my sound.
Really wasn't even a question. We hijacked it.
What?
I don't think this was even asked.
No, yeah, you hijacked it, but it's all good.
This is, yeah, we went a little bit south, but that's okay.
It's all good. All right, hopefully you can hear this.
Wow.
So the answer to the mysterious magical sunset phenomenon, as what's
You can hear it?
Yeah.
his face was talking about, is really just as simple as knowing what the sun is, knowing that it's in apparent position, and knowing how to accommodate for it with the limit of vision. Right. So when the sun rises, here's what we see. Oh, it rises and sets, and you see it's perfectly on the equator right here. It's perfectly symmetrical, right in the middle. Okay, super easy. So there's the one sunset, totally explained. Let's go ahead and either change the time of year or change our latitude. We can do both, because that's what determines the angle of the sun on every model, by the way, not just ours. Here we go. Let's move it, let's say inward. And then here we have a nice little arc. When it comes back around, that's how we get this wonderful arc sunset going south. Wow, look at that arc. That's crazy. And then actually we can go back to a different latitude and we'll get, say, the inverse. We'll go over here. And it's a little bit north. Oh, wow, look at that sunset. Wow, sunrise, sunset. And look at the arc. And we can
Not
also
setting
change
to
the
the
time of
left,
year, because again,
Austin.
this is how we get the analemma, right? Change the time of year. Someone who doesn't understand the different sun angles are latitude dependent over Earth probably has no idea what causes the analemma either, I would say.
That model didn't show the sun going to the left, Austin. That was the whole point. I can't hear you now.
Yeah, we lost your audio there, Austin.
You lost your audio, Austin.
Oh, sorry. If you can admit that it clearly just showed both of them, it shows the, if you understood how it's happening and saw the arc
them
from one
broad
direction, you
goggles
would know
on,
that if
baby.
you had changed the camera angle, it shows the opposite arc, and it arcs back down and falls around to the side of south. So like, yeah, I'm sorry if you don't get it, but we can move on now. Objectively,
you
it
can
just
keep
showed it
saying
go
I
both
don't
ways.
get it. It's,
have to say
it's
no.
absolutely absurd that you're sitting here just like saying things that aren't happening on the screen
Oh, you're
and
getting so
acting like they're
triggered.
happening.
That was your big argument. I'm sorry.
Yeah,
That's-
you want to see suncalc.org?
I just showed you that using stellarium data and understanding the curved visual limit of like say even 3959 equidistant in all directions, you would get the same exact optical
No, now
displacement.
that's a different subject again.
It's the same subject. That's what the model shows.
Let's move into the next question, because yeah, we
Please.
got
He
lots of
doesn't understand
questions.
it. He doesn't understand
I
it.
don't understand it. How
We-
can we move on to the next question if he's going to sit there and just like say?
I
words
just
that
showed
don't mean
everyone. We can move on. Everyone,
Just gonna say words. God damn, he showed you a demonstration. He talked about it. This guy, wow. He don't got no brains in his fucking head at all, man.
just saw it.
Wow, I can't deal with this guy.
You just
You
said
did,
no.
you did not show the sun going south while it's setting in that
Yes.
observation.
Yes, it
No, you
did.
didn't.
Oh my gosh.
All
It's
right,
literally the
we're-
same
we're
exact
spiraling
data
'cause we're
from
both-
Stellarium.
Yeah, I think
It's
we're
not this.
sorry,
Do you
go ahead.
understand that the sun goes to the northeast as it's going around the Earth?
Do you understand
You
this is
understand
built on
that?
Stellarium data?
You understand that it would go this way, whether you're in the northern hemisphere, or the southern hemisphere, or the equator?
People were saying
It
I
would go
took
that
an
way.
L. But let me say this one thing and we should move on. He just pulled up Stellarium to show where the sun's setting.
Yeah.
This program is built from Stellarium's data and showed you the sun setting for the relative observer position
begging the
based on
question-
latitude.
Begging
based
the
on
question is not
latitude,
an
it-
answer.
Okay, so you just said it didn't show it, and now you're saying
You're
it did
saying
show-
because the model shows
just move
it,
on.
Okay,
We're
we're
just gotta
moving
be
on,
fast.
guys.
Earth is
We're
flat.
moving on. We got to move on. Mega
Getting
Fan Dan
debunked
is coming
every
in.
time you speak.
Hold on, hold on, Austin. We got to move on. We're gonna keep spiraling if we don't. Mega Fan Dan says, if the world is a globe and it's spinning, why do I fall in the same place when I jump straight up? I think that question's for you, Globey McGlobeface.
Have to answer that question.
I mean, if you'd like to move on, I mean, we do like to entertain questions.
Okay,
that
sure,
are,
yeah.
properly pointed to the subject.
Conservation of momentum. You're moving with the earth and the atmosphere. When you jump up, you're still moving with the earth and the atmosphere. It's very, very simple.
All
I'm
right.
not sure why that's a confused topic, but you can go watch videos of people on the back of a pickup truck, right? And you jump up or you throw something up in the air, it lands right back to you. Same concept.
All right. Now we got a little bit of a more silly one. We can just kind of move on from here. But
Yo,
LJ,
Sov.
hanging out. Tarzan
Sovereign.
would think Earth is
What's
just
up?
We should all go and stand on top of a pickup truck and start jumping around and see what happens.
Yeah.
We'll probably all end up on the road, and this guy won't understand why.
Here'd be a real good way to check it out too.
Yeah.
Right? Would be, well, I mean, if you've got a high enough height, you will see a difference if it's moving. So if you were on a train, and let's suppose that train had a 40-foot ceiling, okay, and you bounced a ball straight up in the air, okay, and it goes up, 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 up like that, I guarantee you that when it comes down, it's going to come down behind where you bounced it every fucking time. Every time. Because it's had enough time to decelerate. Because it's left its source of acceleration. It's going to start decelerating. And then as it comes down, it would be behind it.
Yeah, and then if you imagine that same scenario, but with a moving surface underneath you, that rubber bouncy ball will do something completely different and end up somewhere over there.
Yeah, that's what I'm saying. If you've got
Yeah.
it back, and so by having it like inside of a boxcar, of course, this is kind of unrealistic, but you can see what would happen because given enough distance, enough time away from the source of acceleration, it's going to drop behind its source of acceleration because it's going to slow down while everything, even the air, is still moving that speed, apparently. But that ball still, it's going to start decelerating, and then by the time it comes back down, it'll be behind it. Absolutely.
And that could be measured as well, and then you could work out what would be the theoretical effect if the Earth was moving, and it obviously would be something totally insane. Like you say, you jump up and you'd land like half a meter behind you.
Well, what was it? Baumgartner, he landed. Where did he? I think he landed like 80 miles the wrong direction, man.
Yeah.
So that's pretty crazy. Oh, the wind. Yeah, it was the wind got him. But I thought the air was going with the earth. Come on. What? So how fast is a eastern wind, right? In reality.
a spinning ball. Thanks for your thoughts, LJ. Yeah, Tarzan swinging through the trees. He's not thinking too much about the old Globy poo. Kango.
All right,
40
so I'm going to cut it right here for tonight at looks like about the halfway mark. And with Kango 44's question for tomorrow night. So yeah, I think 3 hours is good for tonight. Thoughts on it so far, Hanson? Any thoughts on it so far? You're muted, brother.
Oh yeah, just the usual. It sort of descends into kind of proofs and information provided by the flat Earth side until it kind of reaches a point where nothing else can be said and the subject has to be moved on because all we can say at that point is like straight denial.
Yeah.
There's the amount of evidence and information can be pulled up and can be reeled out like endlessly for proof. And, so, this Globey had very, very little to add to the conversation, really.
No, I don't believe. I think he was greatly outmatched.
Yeah,
Globe
that too. Yeah.
was greatly outmatched. From what I've seen, I don't think it would take a whole lot to outmatch him. You know, I think he's. I've never seen him around anywhere before until just recently. Did you?
Oh no, I remember him being around like maybe half a year ago. He was doing
Okay.
debates quite a lot. But I get the vibe off him that he's a bit like the good cop, bad cop. He's like very kind of gentle with it, but then he's using like just tactics to draw like time out and stuff, you know.
Yeah, yeah.
It's a very, you know, like you say, he's more like practice for you know, someone who's learning about debating rather than someone like, you know, that knows their stuff.
Yeah, I mean, this is
Because he
kind of
doesn't
like,
know his stuff. He doesn't have enough knowledge himself to kind of to debate on that level.
he knows the talking points, but he doesn't really understand them, because when you go into dissecting the talking points, then he's lost. He's done. He's all over.
Yeah, and the thing is, he kind of catches himself out because he was like, okay, bring up the data, and then when Whitsitt does bring up the really kind of scientific data, which I like fully admit I don't understand myself, he has to pretend that he's following the conversation, and he's not even like there. He's like, he doesn't even know where he is in that conversation to continue it. That's how out of his depth he is.
He didn't expect his bluff to be called. He didn't expect Whitsitt to have that readily available.
Yeah.
But he should have known better. I'll tell you that, he should have known better. This guy's like on it with his information when he needs to. So, well, I think I'm going to cut it for tonight. This has been a good one.
Okay, thank you, man. I'll be off then.
All right, brother. Thanks for coming on tonight. We'll pick up where we left off tomorrow. We're about halfway through this. It's rather educational, very interesting on both the intellectual and a psychological standpoint too, because I like watching how these people act. It's pretty interesting. Yeah, it was a bit unfair to him. He was using a lot of words, 3-syllable words and more, and that's rough. And like I said, man, sometimes I gotta go, what did he just say? What, you know, and go back and listen to it again and dissect it. And I go, like, all right, I'm not really quite sure what that means, but I'm going to look into that, you know, because this kid's like, he's on it, man. He's definitely on it. So we'll continue this on tomorrow night, and if there's anybody who wants to come on and talk about the shape of gas, the shape of air, that'd be a good thing too, because that's one that you can play with there. Think about that. And until tomorrow, just remember, the Lord loves the working man. Don't trust whiting. See your doctor and get rid of him. He'll probably kill you. We'll catch you tomorrow evening. Good night.